Hello there and welcome back to the Sleep Science. Tonight we're gazing outward, far beyond your quiet bedroom ceiling, to the deep black sweep where 3I/ATLAS drifts like a question mark written in ice. The telescopes have already seen it, though you haven't. They caught it glinting against the stars near Pegasus, a dim smudge moving just slightly too fast. You probably won't survive this in any literal sense. None of us will, really, because by the time it loops past the sun and coasts back out again, every human life that noticed it will have long since faded. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop your location and your local time in the comments. I love knowing where on earth this sleepy little expedition reaches. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You see it first as a blurred pixel on a live feed, a tiny fleck shifting against a tapestry of stars. Astronomers have labelled it 3I/ATLAS, the third interstellar object ever recorded passing through our solar system. 3I for Third Interstellar, ATLAS for the Hawaiian Survey Telescope that spotted it. The naming feels bureaucratic, almost unimpressive, but the reality behind those letters is staggering. This thing came from somewhere beyond our sun's dominion, and it's just strolling through like a tourist with no itinerary. You picture it moving soundlessly through a darkness so complete that light itself hesitates. Instruments show it's faintly blue-green, a typical coloration for comets, yet the brightness fluctuates, pulsing irregularly, as if it's flashing Morse in a language no one knows. The first few nights, astronomers argue about its orbit. One team swears it's bound to the sun, another insists it's hyperbolic, meaning it will never return. You sit there in your dim room, one tab open to a live tracker, the other to a newsfeed full of cautious optimism and gifs of old Comet cartoons. Probably just another icy rock, says one astronomer on a podcast. Her tone calm, measured, the kind of calm that either means confidence or terror. You can't quite tell which. Historically, humanity has met such visitors with curiosity tempered by existential unease. When the Great Comet of 1680 appeared, the public thought it was an omen of divine wrath. Meanwhile, Isaac Newton calculated its orbit and quietly revolutionized physics. 3 centuries later, in 1910, Halley's Comet swung by again, and newspapers sold anti-comet pills to ward off its allegedly poisonous tail. Historians still argue whether those pills were satire or genuine grift, but either way, people lined up to buy them. Now it's 3I/ATLAS and we're supposed to be rational. No anti-comet pills this time, just memes, data plots, and 1,000 anxious Reddit threads asking if it's another Oumuamua. The official images show a fuzzy nucleus surrounded by a thin coma. Nothing unusual, except the coma keeps distorting as if responding to something unseen. One researcher calls it an object with commitment issues. It can't decide whether it's a comet or an asteroid. The joke lands barely. Another adds, it's like it's self-editing its behaviour. That part isn't as funny. You close your eyes and imagine standing on its surface, a lumpy plain of rock and volatile ice, the faint whisper of solar radiation heating one side until it vents gas, sending it tumbling through nothingness. You feel small, you are small. The entire human species could vanish tomorrow, and 3I/ATLAS would never notice. Still, the mind rebels against insignificance. You catch yourself giving it a personality. Maybe it's shy, hiding behind its coma. Maybe it's lost, wandering between stars, an interstellar orphan. Or maybe, a quieter thought whispers, maybe it's looking. There's an odd calm in watching something that has no interest in you. That's part of the cosmic therapy of astronomy. The universe isn't out to get you. It doesn't even know you exist. Yet with 3I/ATLAS, that detachment feels strained. The orbital models refuse to settle. Each update tweaks the parameters slightly, suggesting that some small persistent force is nudging it. Something other than gravity or the predictable push of sunlight. When Oumuamua was discovered back in 2017, it caused similar headaches. It accelerated subtly as it left the solar system, and to this day, astrophysicists can't quite agree why. Some say it was outgassing like a comet. Others think it was a shard of hydrogen ice that sublimated invisibly. A few fringe voices, always the fringe ones, hinted at artificial origins, some long-dead probe wandering the void. Historians still argue whether that reaction said more about the object or about us. You smile faintly, thinking how every generation finds a mirror in the sky. In 1910, comets reflected our fear of poison and plague. In 2017, Oumuamua reflected our fascination with aliens and our anxiety about being alone. Now 3I/ATLAS reflects our fatigue, the feeling that the next cosmic surprise might be one too many. You scroll through the comment section of the observatory livestream. Someone writes, "If this one's weird too, we need to have a meeting with the galaxy's HOA." Another replies, "Maybe it is the HOA." You laugh softly. It's late, your coffee's gone cold, and outside the window the autumn sky glows faintly with city haze. Somewhere up there, the comet slides silently onward, utterly indifferent. Still, the silence feels heavy. You think of the radio telescopes already turning to listen, the analysts preparing algorithms to detect faint signals in the noise. It's all part of the modern ritual. Spot a mystery, measure it, hope it behaves. But 3I/ATLAS doesn't behave. Its reflectivity changes unpredictably, its tail blooms and vanishes, and the light curves defy simple equations. If you were writing a movie script, you'd make it the herald of something larger, the scout before the fleet, the first knock on the cosmic door. But this isn't fiction, at least not yet. For now, it's just another visitor cutting through our system, carrying secrets from stars we've never seen. You lean back, let the faint hiss of your fan fill the room, and imagine that hiss stretched across the cosmos, the same low hum that every astronomer hears when the data feed goes quiet. A noise that isn't quite noise, a silence that isn't quite empty. 3I/ATLAS keeps moving, a small luminous comma in the great sentence of the galaxy. And though it doesn't speak, you can't shake the sense that it's pausing for effect, waiting for us to finish reading. You keep refreshing the feed, watching that faint dot crawl pixel by pixel across the digital starfield. The comments scroll faster than you can read. This looks familiar. Same vibes as Oumuamua. Deja vu, but with frost. They're not wrong. The resemblance is uncanny. Another elongated object from interstellar space, another orbit that screams not from here. You remember the first time you heard the name Oumuamua? It was 2017, and for a week the entire internet turned into an astronomy forum. That long cigar-shaped rock swooped in, ignored every expectation, and left before anyone could agree what it was. Scientists argued over its brightness curve like art critics dissecting a cryptic painting. Some swore it was tumbling, others that it was flat like a pancake. When it accelerated mysteriously, the conspiracy mills churned to life. "Solar sail," one group cried. "Outgassing," countered another. Historians still argue whether that debate marked the birth of modern interstellar studies or the moment pop culture officially hijacked astrophysics. Now, 8 years later, you're living the sequel. 3I/ATLAS is smaller, dimmer, colder, and far less cooperative. Yet the echoes are unmistakable. You feel that same electric tension, that same collective inhale before anyone knows whether to be thrilled or terrified. You picture the conference rooms where astronomers once dissected Oumuamua's data, whiteboards covered in parabolas, laptops glowing with simulation code, someone in the corner saying, "What if it is artificial?" followed by nervous laughter. That same laughter hums beneath every mention of 3I/ATLAS. No one wants to sound unscientific, but no one can ignore the coincidences either. A sleepy-voiced presenter on a science podcast calls it Oumuamua's ghost cousin. She's joking, but something in the tone sticks with you. Ghost cousin. A fragment of a fragment, maybe a shard from some ancient collision ejected from another star system. You imagine it drifting for millions of years through interstellar darkness, bombarded by cosmic rays, frozen and refrozen, the perfect survivor of nowhere, and yet somehow it found us. It's strange to think how tiny our detection window really is. The solar system is a vast, invisible bubble of space, and only a handful of instruments can even spot something this small and faint. In another timeline, 3I/ATLAS could have slipped through unnoticed, brushing past our planet without leaving a trace. You'd still be scrolling through news about elections or streaming updates, none the wiser that an interstellar relic had just whispered by. The discovery came late in March, right when the nights began to warm. Atlas, the asteroid terrestrial impact last alert system, lives up to its melodramatic name by scanning the skies for anything that might crash into us. Usually it catches near-Earth rocks a few days before they swing by, but this time its algorithms flagged something moving far too fast to be local. Within hours, observatories in Chile, South Africa and Arizona were all pointing their scopes at the same coordinates. It's a moment reminiscent of 2017's Scramble. Back then, Pan-STARRS had caught Oumuamua purely by luck, and astronomers worldwide pulled all-nighters to chase it before it vanished. This time, they were ready, or at least they thought they were. The world's instruments synchronized like an orchestra waiting for the first note, only to find the melody kept changing key. The early data suggested 3I/ATLAS was roughly 150 meters across, smaller than Oumuamua but more reflective. The reflectivity, or albedo, danced unpredictably, as if parts of it gleamed metallic while others absorbed light like charcoal. Comets usually shed gas as they warm, but this one remained stubbornly quiet, its coma faint and uneven. "It's like a comet that forgot how to be a comet," quipped one astronomer during a live stream. "A cosmic introvert." You grin at the phrasing. Cosmic introvert. You know the feeling. The mainstream media handled it with cautious curiosity. No tabloids screaming alien ship yet. But fringe corners of the internet lit up instantly. Threads with titles like Oumuamua 2, The Reckoning, and Proof They're Watching Again multiplied overnight. Someone claimed to have spotted a blink pattern in the time-lapse images. Proof, they insisted, of structured communication. Someone else pointed out the obvious. If it wanted to say hi, maybe it could pick a method we can actually read. And through it all, scientists kept comparing the datasets. The similarities weren't just visual. Both objects arrived from roughly similar galactic latitudes. Both had trajectories that barely grazed the inner solar system. Both accelerated slightly, inexplicably on departure. Coincidence? Possibly. But coincidences, like caffeine, are addictive. Theories sprouted faster than weeds. Some said 3I/ATLAS was a fragment of the same parent body as Oumuamua, 2 chips off the same interstellar iceberg. Others proposed that both were part of a larger unseen debris stream, tracing a ghostly filament across the galaxy. One particularly ambitious preprint even argued for a galactic courier hypothesis, suggesting an advanced civilization might seed multiple systems with durable information-carrying objects. The paper was pulled within days, but screenshots live forever. You pause to stretch, listening to the hum of your fan, the only wind in your private observatory. The irony isn't lost on you. Humanity, collectively, is staring into the void and asking whether the void might be writing back. The deeper you read, the more you notice how everyone's trying to tame the mystery by giving it a narrative. Some call 3I/ATLAS a visitor, some a messenger, others an accidental tourist. But all those words assume intention. Maybe it's simpler and lonelier than that. Maybe it's just an orphan rock obeying physics we don't fully understand. Still, something nags at you. Every new observation seems to deepen the resemblance to Oumuamua while adding a new contradiction. The rotation period doesn't fit the mass estimate. The colour index shifts slightly blueward every week. A minor planet's trajectory, series of all things, shows a minuscule perturbation that shouldn't exist. Nothing dramatic, just enough to raise eyebrows in the data rooms. You picture the astronomers exchanging messages late at night. "Are you seeing this? My model broke again. It can't be right." When Oumuamua left, many felt a strange emptiness, like missing a train you didn't realize you were waiting for. The universe had sent us a visitor, and we'd barely said hello. With 3I/ATLAS, that feeling returns, but this time you sense people are more prepared, more alert, maybe even a little afraid. You take another sip of now lukewarm tea, staring at the ghostly dot on the screen. Somewhere out there, beyond the reach of our warmth, something ancient glides silently past our sun, retracing the path of a mystery we still haven't solved. And as the Earth spins beneath you, you can't help but wonder, are we watching it? Or is it watching whether we've learned anything since the last time a stranger came calling? You tell yourself you're not going to stay up late tonight. Just one more update from the Minor Planet Center, one more check on that trajectory line, and yet here you are again, screen glow, half-empty mug, a quiet apartment breathing around you, waiting for a dot of light hundreds of millions of kilometers away to decide what kind of object it wants to be. The analysts keep calling it silent, not metaphorically, but observationally. For weeks now, 3I/ATLAS has refused to emit the sort of predictable signals a comet should produce. No steady jetting of gas, no symmetrical tail, no comforting outburst of dust to confirm that, yes, this thing is melting in sunlight like every good comet before it. Instead, its emissions flare irregularly, as though something internal switches on and off according to its own inscrutable logic. You zoom in on the latest photometric data. The light curve should rise and fall in a smooth rhythm, following its rotation. But it doesn't. It hiccups. 3 peaks close together, then a long flat line. The official description calls it a periodic modulation. You call it creepy blinking. Historians still argue whether Oumuamua was truly silent or whether we simply lacked the ears to hear it. A few claim to have detected a faint radio signature at certain frequencies, though later analysis chalked that up to terrestrial interference, one enthusiastic ham operator's microwave oven to be precise. Apparently in 2017, someone reheating soup created one of the decade's most confusing data spikes. Science, as always, keeps its sense of humour, but this time the arrays are better prepared. You picture the great dishes, Arecibo's successor in Puerto Rico, the meerkat in South Africa, the behemoth fast in China, each one tracking that wandering dot across the void. You imagine the operators leaning close to their monitors, listening to the electronic hush, the faint hiss of cosmic background, and hearing nothing. That's what unnerves you most, the nothing. Silence has texture, you realise. The deeper you listen, the more you begin to hear its shape. The radio spectrograms are empty, yes, but not quite. There's an eerie regularity to the noise floor, a smoothness too precise to feel random. Some amateur analysts online claim to have found gaps, tiny bands of missing static repeating at intervals. Others dismiss it as algorithmic artifact. Still, you find yourself turning down the lights and leaning closer, as though proximity might make the pattern speak. You chuckle softly at your own absurdity. You're not an astrophysicist, you're just another sleepless observer with an internet connection. But the silence feels personal somehow, as if 3I/ATLAS is testing your patience. The official line remains calm. Interstellar object exhibits non-gravitational acceleration consistent with outgassing. That same phrase again. They used it for Oumuamua too, though no gas was ever detected. A century from now, textbooks might describe both with equal nonchalance. Visitors from interstellar space, chemical composition uncertain. The blandness of history can be comforting that way. You scroll down the discussion threads. Someone has overlaid the new trajectory data on a map of the solar system. The line curves slightly closer to the sun than predicted, just enough to raise suspicion that something, perhaps even solar wind pressure, has changed its course. You trace the line with your cursor, feeling that twinge of déjà vu again. Maybe it's surfing, someone jokes, catching photons like waves. You laugh quietly, imagining a cosmic surfer crouched on a frozen board, slipping through light like it's water. But the idea isn't entirely fantasy. Some scientists still entertain the solar sail hypothesis, a thin, ultra-reflective sheet propelled by starlight. Oumuamua's unexpected acceleration matched such behaviour uncannily well. Historians still argue whether that theory was bold science or desperate poetry. Whatever 3I/ATLAS is, its path refuses to settle. The orbital solutions shift every few days, tiny adjustments that compound into big questions. If it's just a comet, its jets must fire with mathematical perfection to produce these precise nudges. If it's something else, well, that sentence never finishes. You step away from the screen for a moment, letting your eyes rest. Outside, the night sky hangs above the city like an inverted ocean, faintly orange from streetlights. You know 3I/ATLAS is up there somewhere, invisible to the naked eye, sliding across constellations that ancient sailors once used to navigate. Back then, a new comet meant change, good or bad, depending on the storyteller. In 44 BCE, a comet appeared after Julius Caesar's assassination. The Romans called it Caesaris Cometa, the soul of Caesar ascending to the heavens. Historians still argue whether that belief was genuine faith or clever propaganda, but the omen stuck. Now, 20 centuries later, we see a new comet and think not of emperors but of algorithms. Progress, you suppose. Your phone buzzes, a new alert from an astronomy forum. Someone claims the comet's spin rate has slowed. You pull up the thread and read through the frantic comments. The rotation period appears to have lengthened by nearly 10% over a week. Impossible, unless mass is being redistributed, or unless something is exerting torque from outside. Theories range from uneven outgassing to magnetic interaction to the obligatory alien probe posts. You close your eyes, listening to your own breathing sync with the fan's whisper. In this low light, imagination fills in the gaps that science can't yet explain. You picture 3i/ATLAS, not as a comet or a craft, but as a survivor, something ancient and scarred, maybe once part of a planet, now wandering between stars with a secret only silence can keep. Then, for a heartbeat, you imagine it noticing us back. Not with curiosity or malice, but with that same faint awareness you feel when you realize you're being observed through glass. The thought chills you, though you smile at the melodrama of it. You've watched too many documentaries, maybe too much late-night speculation. Still, you glance at the time. It's past 2 a.m, and the comet will be at perihelion soon, closest to the sun, brightest in the sky. The telescopes will have a brief window to catch any flare, any whisper, any proof. After that, it'll begin its long retreat into darkness, taking its silence with it. You make a quiet promise to yourself: if the data tomorrow shows nothing, no signal, no anomaly, you'll let it go. You'll sleep again. But you already know you won't. Because even if 3i/ATLAS is just a rock, its silence has become a conversation, and you can't help but listen for the next word. Somewhere, behind the hum of your devices, behind the low urban wind, there's another hum, older, slower. Maybe it's just the sound of your heartbeat aligning with cosmic emptiness. Or maybe, just maybe, it's the space between 2 words in a message still being written. The equations blur on your screen like static through water. You've been staring at orbital models for hours, pretending you understand what any of it means. The software renders graceful arcs, all color-coded possibilities. Green for gravitational, blue for photometric, red for please don't trust this yet. The red ones multiply every time new data comes in. You begin to suspect the comet isn't misbehaving, it's the math that's tired. You picture the scientists on the other end of the feed, faces illuminated by dual monitors, arguing gently over decimal places. Someone types, someone sighs, someone reaches for cold coffee. The same ritual Newton himself would recognize. Numbers versus nature, both refusing to blink first. Historians still argue whether Newton's obsession with comets was pure curiosity or quiet terror. He once wrote that their unpredictable paths threatened the order of the heavens. Tonight, as 3i/ATLAS keeps rewriting its own coordinates, you feel that old fear echoing across centuries. A mainstream article tries to summarize the problem for normal people. The object's acceleration does not fit known outgassing models, which translated means the math won't sit still. One moment, the simulation shows it passing harmlessly beyond Mars. The next, it flings outward like a skipped stone, velocity off by fractions that compound into millions of kilometers. Those fractions shouldn't exist, yet they persist. Little ghosts of error haunting every calculation. You zoom in on one graph showing the non-gravitational parameter, a fancy way of measuring how much the comet refuses to behave like a rock. The line isn't a line anymore, it jitters, it pulses. A senior astronomer posts a half-joking comment on social media: "Our comet is gaslighting us." The thread fills instantly with puns. Comet gaslighting, get it? You chuckle, grateful for the humour. In science, laughter is the last defence against the abyss. Still, the abyss doesn't laugh back. Your inbox pings with an alert from a data sharing group. A new paper draft, unpublished, unsigned, circulates among a few insiders. You shouldn't have access, but leaks travel fast in the age of cloud drives. The document's title reads, Preliminary Assessment of Variable Acceleration in 3i/ATLAS. The abstract is calm, clinical. The conclusion isn't. Observed modulation suggests an external or internal mechanism inconsistent with isotropic sublimation. Possible explanations include directed jets, rotational instability, or non-natural periodic thrusting. You pause on that last phrase, non-natural periodic thrusting, as if the words themselves are embarrassed to appear together. Whoever wrote it added no elaboration. You stare for a long moment, torn between excitement and unease. The equation diagrams in the appendix look like musical notation, lines, oscillations, pauses. You wonder if the comet has rhythm. Outside, dawn begins to grey the window. You stretch, the kind of slow spinal ache that comes from too many hours of sitting still. The city is waking, oblivious to the fact that the universe just lobbed another riddle our way. You remember reading that? In 1705, Edmund Halley proved his namesake comet returned every 76 years. People thought he'd done magic. The truth was simpler. He trusted math. You wonder what Halley would say if he saw your flickering red error bars. Maybe he'd shrug, sip his ale, and remind you that math is just a lantern. It doesn't make the cave any smaller. A notification chimes. The European Space Agency has updated its trajectory model. You open the file, eyes bleary, and watch as their curve differs subtly from NASA's by a few arcseconds. Journalists won't care. Numbers that small don't sell headlines. But to orbital dynamicists, it's heresy. Somewhere in those arcseconds hides a clue. A push, a pull, a whisper of force. You imagine what could cause such a whisper. Outgassing. Sure, but we've seen no coma consistent with that. Maybe an uneven surface reflecting light pressure differently, creating microthrusts. Maybe a composition so strange our assumptions fail. Or, your inner conspiracy gremlin perks up. Maybe there's something inside, like an ancient seed pod adjusting itself to solar warmth. You roll your eyes at yourself, but the image sticks. There's precedent for natural oddities after all. In 1986, the European probe Giotto flew past Halley's comet and discovered it darker than coal, albedo lower than asphalt. That single observation rewrote textbooks. A dirty snowball, they'd called it. In truth, more like a snowy lump of soot. Historians still argue whether that discovery marked the end of romantic astronomy. The moment comets stopped being omens and started being chemistry. Yet here you are, centuries later, watching the math misbehave and feeling superstition stir again. A live stream from the Lowell Observatory plays softly in another tab. Two astronomers speak in the gentle cadence of people, pretending not to panic. They display the latest residuals, the discrepancies between expected and observed positions. The dots should scatter randomly. Instead, they form a faint spiral. It's likely noise, one says quickly. Pattern recognition bias. You squint. It does look like a spiral. Could it be precession? Maybe the object is tumbling, exposing facets that reflect sunlight differently. That would explain the brightness changes. But it doesn't explain the steady drift off course. You realize with a shiver that the spiral's direction corresponds not to the sun, but roughly to the galactic plane, as if the object is orienting itself toward home. You tell yourself it's coincidence. Coincidences are cheaper than panic. You jot a few notes, pretending you're part of the analysis team. The act feels comforting, even if it means nothing. Numbers are a way to talk back to the unknown. Then a headline pops up on your feed. 3I/ATLAS exhibits unmodeled acceleration. NASA recalculates approach window. The accompanying graphic shows the comet's new path threading slightly closer to Earth's orbit, still millions of kilometers away but close enough to make the public twitch. The comments range from neat to we're doomed. Someone quips, if it's an alien probe, it's running Windows Update mid-flight. You actually snort at that one. Humor again, the most human of force fields. By late morning, the article vanishes, replaced with a sanitized update emphasizing no threat to Earth. You've learned to read that phrase as code for, we're still figuring this out. The day brightens, sunlight spills through your blinds. You should sleep, but your brain hums with equations and what-ifs. You think of those researchers across the globe crunching the same numbers, chasing the same phantom accelerations. Each keystroke, each recalculation, each frustrated sigh adds another verse to a collective lullaby humanity keeps singing whenever the universe refuses to explain itself. You lean back, rubbing your temples, and whisper to no one, show us your math, little comet. But 3I/ATLAS, true to form, stays silent, its mysteries folded neatly inside a calculus that seems to mock its creators. The models will keep shifting, the spreadsheets will keep pulsing, and the silence between numbers will deepen. Until maybe, just maybe, the math itself starts whispering back. The next phase begins with radio. It always does. Because when light lies, or at least refuses to answer, you turn to sound, or what passes for sound when filtered through static, frequency, and the patient hum of machinery listening to nothing at all. You picture the dishes again, those white concave mirrors of curiosity, turned upward in perfect silence. Fast in Guizhou, with its bowl the size of 30 football fields. Meerkats' clustered antennas stretching across the Kru Desert like a mechanical bouquet. The revived Allen Telescope Array in California humming softly in night air, scented with dust and sage. They are humanity's biggest ears, and tonight, every one of them is listening for 3I/ATLAS. It's called a multi-point correlation sweep, a fancy phrase meaning if there's a whisper, we'll catch it somewhere. Engineers feed coordinates and time codes into synchronization algorithms, adjusting for light travel delays down to the microsecond. Every byte of background noise is logged, compressed, and shared across data hubs. You imagine that torrent of digital static racing through cables and satellites, wrapping the planet in invisible threads, and yet, when all the servers finish their work, nothing. No pulse, no carrier wave, no weird repeating interval that could hint at structure. Just the steady, snow-coloured hiss of the universe itself. At first, everyone's calm, it's what they expected. Most comets are silent radio-wise unless they outgas heavily, but 3I/ATLAS isn't behaving like most. The brightness flickers, the orbit drifts, and still, silence. Somewhere in the mix you sense the tension rising. A late-night broadcast from the European Space Operations Centre streams in. A tired-looking technician in a rumpled sweater explains that the new data doesn't necessarily disprove non-natural hypotheses. That phrase doesn't necessarily send social media into overdrive. Within minutes, the clip is trending under the tag #Whispergate. Historians still argue whether the 1967 discovery of pulsars triggered the same kind of thrill. Back then, the first radio signals from deep space were so precise, like clock ticks, that their discoverers labelled them LGM-1, Little Green Men 1. It turned out to be a neutron star, of course, spinning and beaming like a cosmic lighthouse. But that first moment of wonder, human ears catching rhythm from the void, feels familiar tonight. You can almost hear the hum through your headphones, the broadband hiss stretched into something that sounds like an ocean in reverse. You adjust the volume lower and imagine yourself on the edge of the solar system, the comet sliding past, silent except for the ghost of its own momentum. Then comes the first rumour. A private observatory in New Zealand claims an unidentified low-frequency dip in the signal. Barely above background noise, but consistent across 3 nights. A scientist tweets a cryptic line, "If it's nothing, it's a very consistent nothing." The post vanishes an hour later. The forums ignite. You scroll through pages of speculation. Gravitational lensing artifacts, Earth-based interference, coded communication, even the possibility that the silence itself might be structured. Someone overlays the spectrogram's quiet zones and discovers an evenly spaced pattern of absences, like the missing bars in a piece of music. Another user calls it negative Morse. You try not to get swept up, but the idea has teeth. Silence as signal. It sounds poetic, even logical, in a universe that seems to favour riddles over revelations. You think about how radio silence can be its own language. During the Cold War, submarines communicated by not transmitting. Pauses, durations, deliberate absences. Whole strategies of meaning built on what wasn't said. Maybe 3I/ATLAS, whatever it is, follows a similar logic. Then again, maybe it's just a frozen rock doing rock things while humans project their fears onto its quietness. A professor from Cambridge posts a level-headed explainer video, her tone as soothing as chamomile tea. "We're dealing with confirmation bias," she says. "We expect mystery, so we find it, even in static." She smiles kindly at the camera. You believe her for half an hour until a leaked memo surfaces suggesting multiple agencies have quietly reserved telescope time for repeat pattern verification. It's the kind of contradiction you can't help but savour. The world insists there's nothing, while paying millions to double-check that nothing again and again. By midnight, a few sleepless enthusiasts compile the entire week's radio data into a single audio file. You download it, half out of curiosity, half out of stubbornness. When you hit play, a wash of white noise fills the room. It's hypnotic, oceanic, strangely soothing. You let it run while you lie back, eyes closed. After a while, you think you hear faint fluctuations, like breath spaced too evenly. You know it's pareidolia, your brain's habit of sculpting patterns out of chaos, but you still count them. 1, 2, 3, pause. Maybe it's coincidence, maybe it's heartbeat. Your phone buzzes again. A message from a friend who works at a university observatory. Our team's pulling an all-nighter. They say the silence isn't random. Don't quote me. You stare at the text for a long time. The hum from your speakers fills the apartment like gentle wind. Somewhere out there, that dim traveller keeps gliding through vacuum, refusing to speak in any way you expect. You realise the irony. The more silent it is, the louder humanity becomes. The quieter the sky, the noisier the world beneath it. Scientists, journalists, conspiracy theorists, all buzzing like electrons around a nucleus of mystery. It's beautiful in a way. The universe gives you nothing, and you answer with everything you've got. You turn off the audio feed, but the phantom hiss stays in your ears. You whisper, "Say something," knowing it can't hear you, knowing maybe that's the point. And in that suspended quiet, the silence stops feeling empty. It feels deliberate. Maybe the message was never in the transmission. Maybe it's in the pause between them. You wake later than intended, blinking through half-drawn blinds. The first thought that floats up, before coffee, before phone, is it's still out there. The second, and it's still quiet. Outside, a pale autumn light paints the buildings in that soft blue that makes everything feel both real and slightly ghostly. You stretch, muscles stiff from the kind of sleep that's really just unconscious waiting. The morning news already loops the same headline. Earth's third interstellar visitor confirmed, 3I/ATLAS. The anchors pronounce it like a secret code. Behind them, the graphics department has done its best. An animation of a glowing pebble drifting past cartoon planets. It looks harmless, almost cute. You exhale, amused. If only it were that simple. They call it an interstellar comet, but everyone online has shortened it to just the visitor. The name feels personal now, as if the object belongs to all of us. You click through the live tracker again. There it is, faint, bluish, moving toward perihelion. Its path threads the inner solar system like a signature curling across parchment. You pull up a timeline of interstellar objects, our growing drift club, as someone cheekily dubbed it. First came Oumuamua in 2017, the one that started the modern obsession. Then in 2019, the second, 2I/Borisov, discovered by an amateur astronomer named Gennady Borisov from his personal observatory in Crimea. Unlike Oumuamua, Borisov looked every bit the comet, bright, tail streaming, chemical emissions normal. Historians still argue whether its ordinariness disappointed or comforted people. After the weirdness of Oumuamua, Borisov's boring behaviour felt like a sigh of relief. See, not every traveller from beyond is an enigma. And now, 3I/ATLAS, the middle child no one expected. You scroll down to a chart comparing all three. There's something elegant about it. 3 lonely trajectories slicing through our sun's sphere of influence, each from a different direction, each leaving behind a faint trail of recalculated theories. Oumuamua, high speed, no coma, strange acceleration. Borisov, comet-like, expected behaviour. Atlas, faint coma, inconsistent data, questionable silence. You can't help noticing the rhythm forming. Weird, normal, weird again. The cosmic coin is flipping and you're starting to suspect it's weighted. Across the globe, the so-called Interstellar Object Task Group releases another statement. Calm, bland, but hiding fatigue between the lines. Ongoing observations continue to refine the object's trajectory and physical characterization. Preliminary findings indicate a likely natural origin. You've learned to translate. That means we don't know yet, but please don't panic. But no one's panicking exactly. The world's response feels different this time. People are curious, but there's also a subdued reverence, like we're slowly realizing how porous our solar neighborhood really is. It used to be easy to think of the sun's gravitational field as a fence. Turns out it's more like a fog, thin, transparent, and impossible to defend. You think about that for a while, about how many billions of years the galaxy has been swapping pebbles between stars. Every collision, every ejection, every rogue planet slings a bit of debris outward, and occasionally one of those fragments wanders into our patch of light. You imagine the Milky Way as a vast, slow dance of exchange. Star systems trading souvenirs without ever meeting face to face. A soft chime from your phone, another message from your observatory friend. Sleep, number. We've confirmed a faint dust tail. Composition's off. Too much nickel, not enough carbon. like it was forged, not frozen. You reread that twice, feeling the words settle heavy behind your ribs. Forged, not frozen. That phrase starts appearing everywhere within hours, always in quotation marks, like it's a rumour no one wants to claim ownership of. Most comets are ancient snowballs mixed with rock and carbon compounds. Nickel implies something metallic, something that's been heated and cooled repeatedly. You try to picture how that happens naturally, drifting between stars for eons. Maybe it collided with something, or maybe a quieter thought suggests it was made. You shut that thought down quickly. Too cinematic, too conspiratorial. Yet the idea clings, the way static clings to fabric. To distract yourself, you dive into history again. In 1729, astronomers spotted what they believed was the brightest comet ever seen, later named Comet Sarabat. It appeared suddenly, burned fiercely and vanished forever. Its origin never explained. Some modern researchers think it might have been interstellar too, our first unknown visitor centuries before the word interstellar meant anything. Historians still argue whether the old records support that claim. You imagine those 18th century stargazers scribbling in candlelight, unaware that they might have glimpsed the start of a story we're only now learning to read. You check the forums again. Amateur astronomers around the world are organising a watch night. Thousands plan to aim telescopes, cameras, even smartphones at the same region of sky when ATLAS reaches its brightest. Someone posts a map. Follow the visitor. A little cult of cosmic appreciation forming in real time. You smile. Humans are predictable that way. Give us a mystery in the heavens and we'll turn it into community. Half science, half seance. As evening slides in, you step onto your balcony with a thermos of tea. The air carries that faint metal bite of cold weather coming. Somewhere above, hidden by city haze, ATLAS glides along its line. You think of all those eyes turned upward tonight, farmers, students, insomniacs, dreamers, each person tracing the same invisible guest and feeling a little less alone. A breaking news notification buzzes. Minor gravitational anomalies detected near Asteroid Pallas. Possible influence from interstellar object. You read the headline twice. It's small, almost an afterthought, but it's the first sign that ATLAS might be nudging more than just curiosity. In the background of the report, a spokesperson assures the public that gravitational perturbations of this scale are expected. You know enough by now to catch the euphemism. Expected means explainable later. You picture the object sailing quietly between Mars and Jupiter, passing the outer belt where ancient rubble circles endlessly. Maybe one of those chunks felt a tug, the faintest gravitational handshake. If Atlas really has mass dense enough to shift an asteroid's path, it's heavier than we thought. Too heavy for ice alone. You sip your tea and murmur, half to yourself, "So what are you made of, traveller?" The steam rises in the cool air, a ghostly twin of the comet's fading tail. Below, cars move like fireflies. Above, silence. You think again of that growing list. Oumuamua, Borisov, ATLAS. 3 dots on a galactic map. You wonder what the fourth will be like, and whether anyone will still bother to call them visitors by then. Because maybe they're not visiting. Maybe we're the ones living inside someone else's neighbourhood, just too sleepy to notice the neighbours passing by. You finish the tea, feeling both grounded and unmoored. Somewhere in that endless black ocean, the nickel-bright stranger keeps drifting, stubbornly silent, as if waiting for us to understand a language that doesn't need words at all. It starts with a rumour and a redacted PDF. A graduate student on an astronomy forum claims that a handful of telemetry files have disappeared from the open access repository used by the International Survey Network. Not missing, replaced. Each one now a neat block of black bars where numbers should be. You don't intend to care. You've promised yourself a night off from cosmic drama, but curiosity, like gravity, ignores promises. By midnight, you're back at the screen, scrolling through threads titled "Inside the Data Vaults." According to the whispers, the erased files come from an early observation window, those first frantic nights when ATLAS's brightness curve made no sense. A few enthusiasts post screenshots of cached data before it vanished. Irregular light spikes, narrow and perfectly timed, as if a strobe had winked across the stars. Officially, the anomalies were instrumental error. Unofficially, they've become mythology. You think of the way scientists hoard and protect data. Every byte has pedigree, telescope, detector, calibration. If something gets deleted, it's never casual. Maybe a software glitch, maybe someone cleaning up duplicates, or maybe, a darker voice suggests, someone noticed more than they wanted the public to see. There's precedent. During the 1980s, NASA's Pioneer spacecraft recorded mysterious deceleration far from the Sun. For years, chunks of raw data went missing, fueling conspiracy until engineers finally found thermal recoil from the spacecraft's own heat was the cause. Historians still argue whether that explanation was discovered or invented. You try to imagine what the missing telemetry might have shown. Perhaps spectral lines revealing an impossible alloy. Perhaps nothing at all. Just a vacuum mistaken for meaning. Either way, the redactions spread faster than facts. An amateur coder releases a reconstruction tool that stitches the surviving fragments into visualizations. You watch his shaky video, an animation of Atlas's signal over time, the brightness pulsing like a heartbeat, steady, then skipping. Looks like data corruption, he admits, but beautiful, right? It is. Beautiful and wrong. The official agencies push back hard. A new statement appears on their websites, identical wording across continents. Inconsistent datasets have been withheld pending verification. A polite way of saying, stop asking. You've seen enough bureaucratic tone to recognize a defensive crouch. Within days, journalists smell blood. A headline flashes, "What is NASA not telling us about 3I/ATLAS?" The article offers no revelations, only recycled speculation and a blurry screenshot of an email header allegedly discussing data sanitization. The comment section burns for hours before moderators douse it. You lean back, half amused, half uneasy. Maybe this is what modern mythology looks like. Spreadsheets in place of scrolls, leaks instead of prophecies. Each missing number invites invention. Late one evening, your observatory friend messages again. "We didn't delete anything. Some files corrupted during cross-server sync." People love a cover-up though. You ask if she believes that. After a pause, mostly. But there's a weird gap, exactly 43 minutes, where none of the stations logged readings. Not even system noise. That shouldn't happen. You stare at the text, feeling the small hairs on your arm lift. 43 minutes of digital silence. Not a dropout from one dish, but all of them. Global quiet. You try to picture the moment. Every observatory around the world collecting nothing at the same time, like the sky itself muted its feed. You check back through archived forums. Sure enough, on that date the live trackers froze. A few users joked about maintenance downtime. No one realized the coincidence. You whisper, "Did you blink, little comet?" Somewhere a philosopher would remind you correlation isn't causation, that the universe owes you no narrative. You agree, and still you imagine a deliberate pause, a cosmic ellipsis inserted mid-sentence. To break the spell, you dig into another corner of history. In 1892, astronomer E. Barnard discovered the first photographic evidence of a comet breaking apart. 2 nuclei instead of 1. His colleagues accused him of doctoring plates. Only years later did others confirm he'd been right all along. Historians still argue whether that skepticism was caution or jealousy. Either way, it shows how quickly truth can look like heresy when the data misbehaves. You wonder if the same is happening now. Maybe some intern spotted something odd, flagged it, and the higher-ups quietly archived it until they could explain. The cover-up might be nothing more sinister than embarrassment. Science, after all, hates untidy mysteries. Still, the story grows. A YouTuber uploads a video titled "Atlas Files: The Missing 43 Minutes." His voice drops theatrically on words like classified and contact. You roll your eyes but watch to the end, because of course you do. The human brain is a gossip engine. Midway through the video he plays an alleged restored signal, a pulsing tone buried in static. Probably fake. Yet it vibrates at a strangely soothing frequency, close to the rhythm of your heartbeat. You catch yourself breathing in time with it. You laugh nervously, close the tab, and tell yourself you're being ridiculous. But when you turn off the lights, the thought lingers. What if the missing data isn't missing at all? What if the silence was the message recorded faithfully, then deleted because no one knew how to label it? Down in the digital archives, somewhere between human error and human curiosity, a ghost hides in the code. Maybe that's all 3I/ATLAS ever wanted. To remind us that even our most precise measurements have blind spots big enough for wonder to slip through. And as you sit there listening to your own pulse echo the imagined beat of a distant traveller, You realise you've become part of the archive too. Another fragment in the vault, another witness to the 43 minutes when the universe briefly withheld its data, and the silence started to sound like intention. You remember when comets used to be simple. They had tails, they hissed with gas, they flung dust like confetti. Nature's fireworks display predictable enough for classroom diagrams. But 3I/ATLAS refuses to play along. Tonight the conversation has shifted. Not how it shines, but what it's made of. Spectrographs from Hawaii, Chile and Tenerife all agree on the same bewildering result. Its spectrum is inconsistent with ordinary cometary material. You lean over your monitor, eyes following those thin coloured lines that reveal the truth behind starlight. Normally, a comet's light divides into familiar signatures: oxygen, carbon, cyanide, molecules that have been haunting our senses since we learned to read light. But 3I/ATLAS's spectrum carries additional peaks: nickel, magnesium and something unidentified around 390 nanometers, a line that doesn't match any known natural compound. The first official report calls it an instrumental artifact. The second calls it an anomaly. The third stops labelling it at all. A science blogger you follow posts a single sentence: either the comet is lying or our spectrographs are. You chuckle at the drama, but then you notice the raw graphs attached beneath. They're too clean to be mistakes. 3 separate observatories, identical spikes, identical positions. You check timestamps. The data came from simultaneous measurements across hemispheres. Whatever those peaks are, they're real. Someone on the forum coins the phrase forged ice. It sticks immediately, a term that feels both poetic and ominous. The idea spreads that maybe Atlas is composed of materials shaped by heat and pressure not found in nature. Engineered ice, metal latticework, an interstellar composite. Theorists rush to rationalise. Maybe it formed near a supernova, where extreme conditions fused rock and metal in ways we've never modelled. Historians still argue whether similar theories arose after Oumuamua, when one researcher jokingly described it as a defunct solar sail built by someone else's ancestors. You lean back, imagining such craftsmanship drifting through space, a metallic shell covered in frozen gases, masquerading as a comet. If true, then Atlas is not just visiting, it's concealing. Your rational side protests. It's easier to believe in exotic chemistry than alien architecture. So you scroll deeper into technical papers, paragraphs thick with equations, footnotes denser than star clusters. One phrase repeats, non-equilibrium crystalline phase. It sounds like nonsense until you realise it means the ice isn't arranged randomly, it's structured. In most comets, ice forms chaotic, porous matrices, but 3I/ATLAS's reflections imply layered geometry, repetition, order. It's as if, one scientist says during an interview, someone pressed the chaos into neat rows. Someone. That word hangs in the air longer than it should. You watch a replay from the Virtual Planetary Science Conference. A panel of experts sits under the flicker of PowerPoint slides, each taking turns dismantling their own comfort zones. A spectroscopist gestures to her chart. We see lattice symmetry typical of processed metal, not amorphous ice. Another interrupts. Couldn't micrometeoroid impacts cause that? She shrugs. Maybe, but across the entire surface. Their debate is civil, but beneath the politeness you hear fatigue, the sound of scientists realizing the universe has once again ignored the syllabus. Meanwhile, the fringe communities are thriving. You find posts claiming Atlas's reflectivity encodes binary patterns, intentional, mathematical, communicative. Some even map the pulses to prime numbers. Others think it's a coincidence caused by rotational tumbling. The line between data and dream blurs fast in the dark. Then an independent astronomer named Naresh posts high-resolution imagery from his privately funded scope in India. It shows faint hexagonal glints along the object's edge, barely visible, maybe compression artifacts, maybe something else. His caption, "Comet or construct?" Within hours, that phrase becomes the week's meme. Mainstream outlets step in to calm the narrative. CNN runs an explainer titled, "No, the nickel comet is not an alien machine." The article quotes half a dozen experts, all saying roughly the same thing. Extraordinary claims require extraordinary evidence, but none of them can explain the spectral data either. The public loves that kind of tension. You scroll through the comments, watching certainty and speculation duel line by line. Some users post mathematical proofs, others post ASCII art of spaceships. You can't tell who's joking anymore. You close your laptop for a moment, rubbing your eyes. The room hums with quiet machinery. The refrigerator, the fan, the faint buzz of a streetlight outside. All human constructs, each carrying a subtle order that betrays design. Maybe that's what unsettles you most, recognizing yourself in the patterns. If order equals intention, then how would we tell the difference between a natural miracle and an artifact too ancient to remember its maker? You recall a story about the Antikythera mechanism, the ancient Greek clockwork found in a shipwreck. When archaeologists first uncovered it in 1901, they thought it was impossible, too sophisticated for its time. Historians still argue whether it was a singular genius's creation, or proof that entire technologies vanished between ages. Maybe, you think, ATLAS is the cosmic equivalent, an artifact adrift, the lost handiwork of a civilization erased by light years. The idea should feel romantic, but instead it feels lonely. Because if Atlas was built, it means someone out there once looked at the same stars we do, and then disappeared long before we ever noticed. A ping from your observatory friend again. They found nickel-iron ratios matching industrial alloys. Officially unexplained. Off the record. This thing shouldn't exist in space. You type back. So what happens now? Her reply takes a minute. Now we argue. Some want to publish everything. Others want to wait for verification. I think they're scared of what people will decide on their own. You stare at that message, realizing she's right. Fear isn't just about the unknown, it's about losing control of the story. You look out your window. The night sky glows faintly violet, and you imagine that cold, metallic body tumbling silently across the heavens, each facet catching starlight like a slow wink. Forged ice or cosmic coincidence, it doesn't matter. Its silence is a mirror, reflecting humanity's endless need to assign meaning to every shimmer. You whisper to the dark, if you're made, who made you? No answer, of course, just the steady hum of the city, and somewhere above it, the patient glint of 3I/ATLAS, turning like a coin flipped between stars. By now, the simulations are breaking. You watch them crumble in real time, a parade of digital catastrophes on screens that once promised certainty. The models can't hold shape anymore. The more data they ingest, the less sense they make. Your feed fills with phrases like non-converging parameters and chaotic instability beyond tolerance thresholds. Translation: the computers are confused. The math that governs planetary motion, the same equations that can trace a satellite's path decades in advance, fails utterly when pointed at 3I/ATLAS. The frustration ripples through the scientific community like static. Every update, every recalibration, every new variable added to the equation only increases the margin of error. It's as if the object itself mocks prediction, shedding logic as easily as ice. You picture the researchers in dim labs across the world, faces reflected in twin monitors, fingers stained with takeaway coffee. There's a certain poetry in their struggle. Humans versus mystery, once again. They've built models for asteroids, for comets, for exoplanets, for black holes even. But this is a shape that refuses to stay put. One astronomer, half laughing, tweets, "We fed it all our models." It spat back poetry. You know that tone, the humour that edges on despair. A leaked internal memo surfaces later that day. AI simulations have diverged. Output inconsistent across identical datasets. Recommend manual verification. The idea that AI itself can't replicate results rattles everyone. When machines that calculate spacecraft trajectories to the millimetre suddenly start improvising, you begin to wonder what kind of game you're in. You run one of the open source simulators on your own laptop because of course you do. The setup takes half an hour, during which the program downloads a flood of observational data, positions, brightness, radial velocities. The progress bar creeps like a glacier, then the window opens to reveal the same elegant 3D orbit you've seen 100 times. You press Run. At first it behaves. A neat curve spiralling around the sun, brushing Mars's orbit before arcing back out. Then, somewhere near the halfway point, the line fractures. The program freezes. A warning pops up. Error, propagation exceeded valid range. You rerun it. Same result. You try adjusting parameters, rotation, albedo, density. Each time the trajectory splinters differently, like glass hit from another angle. After the fourth crash, you sit back, heartbeat uncomfortably loud. It's not the computer that's broken, it's the input. The comet doesn't belong to equations designed for obedience. Historians still argue whether the failure of Newtonian predictions for Mercury's orbit in the 19th century was the moment modern physics was born. Back then, the planet's path deviated just enough to suggest unseen influence. Some proposed a hidden planet, Vulcan, lurking between Mercury and the Sun. Others admitted defeat until Einstein arrived with relativity. You wonder, half seriously, what kind of new physics 3I/ATLAS is demanding from us now. Meanwhile, AI models built to analyze its light curves start producing strange artifacts. Pixelated spirals, repeating geometries, even what one engineer jokingly calls glyphs. Neural networks meant to find patterns in noise are producing patterns that look intentional. You scroll through one compilation, dozens of generated interpretations, each a blurry tessellation of lines and arcs. Some look like abstract art, others eerily resemble circuitry. When asked, the AI explains nothing. It simply reports that these outputs are the most probable representations of the data. Your friend from the observatory messages again, half our simulations broke. One of the outputs literally spelled noise in blocky artifacts. You type back, coincidence? She replies, that's the problem. It's too coincidental to be coincidence. Some journalists call it data pareidolia, the same mental trick that makes people see faces in toast. But these are machines. They don't dream. Unless, of course, their training sets, filled with human bias and human patterns, have taught them to hallucinate meaning the way we do. A popular science host releases a new video, When the Models Fail, 3I/ATLAS and the Edge of Prediction. His voice is calm, almost soothing, as he explains how chaos theory governs orbits. Small deviations become vast divergences, the butterfly effect. You nod along until he says, but in this case the butterfly's flapping on the other side of the galaxy. It's a good line, you write it down. He mentions something that catches your attention. The Lyapunov time of 3I/ATLAS, basically how quickly small errors explode into unpredictability, is absurdly short, a few hours. For comparison, Earth's is a few million years. That means, practically speaking, the comet's future path is unknowable beyond a single rotation. It's chaos incarnate, and yet somehow the instability seems orchestrated. The deviations repeat in rhythm, every 4 hours like clockwork. When the AI simulations fail, they fail at the same time. You sit there staring at your screen as the idea creeps in. What if the instability is deliberate? A signal disguised as randomness. It's a stupid idea. And yet, you think of historical debates again, this time the 1977 WOW signal. 36 seconds of unexplained radio intensity recorded by the Big Ear telescope. It never repeated, never explained. Historians still argue whether it was aliens or hydrogen gas or a glitch. You realize that once again, we're facing the same script. Something impossible, endlessly replayed through new technology, each generation convinced they're closer to understanding. The only difference is the scale of silence. The day ends with another press release, simulations under review. Observed anomalies likely due to incomplete modelling of outgassing vectors. That phrase, incomplete modelling, feels like a sigh, an admission that the universe keeps rewriting the rules faster than we can print them. You close your laptop, finally, the hum of the fan filling the space where the simulations once whirred. You tell yourself the chaos is normal, that it's part of discovery, but deep down, you suspect something else. That maybe ATLAS isn't broken math, maybe it's showing us ours, because if you squint at the pattern long enough, the noise stops looking random, it starts looking like a choice. You tell yourself you'll just check the sky once before bed, but that single click opens the whole digital night again. The feeds, the forums, the constant refreshing pulse of people who can't sleep. They call themselves skywatchers now, a half-serious name for a half-serious movement. Amateur astronomers, data miners, night shift insomniacs, all chasing the ghost comet through their webcams and backyard telescopes. You join them more often than you'd admit. The main hub tonight hums with images, smudge streaks across pixelated stars, annotated with times, coordinates, focus lengths. In another age, these would have been ink drawings in a leather notebook. Now they're memes with diffraction spikes. Someone jokes, we should start a betting pool. Will it accelerate, decelerate, or just vaporize out of embarrassment? 3 laughing emojis follow. It's funny because the fear underneath it is real. You click through thread after thread until you find one labelled heartbeat confirmed. A user from Finland posts a light curve he's processed from 10 nights of observations. The fluctuations repeat every 4 hours, just like the professional reports mentioned. He's overlaid them with his own pulse oximeter reading for comparison. The match is uncanny. "It's like it's breathing," he writes. You stare too long at the graph, your own chest unconsciously rising to the same tempo. Somewhere between fascination and fatigue, you realise the human brain can turn any rhythm into company. It reminds you of that story from 1965, when astronomers at Jodrell Bank thought they'd found a pulsar emitting regular radio beeps. They nicknamed it LGM-1, the same little green men joke everyone's using again now. Historians still argue whether they laughed because they believed it, or because they were afraid they might. Tonight, laughter fills the digital threads, but underneath runs that same current of awe. The skywatchers keep posting coordinates, refining measurements, even pooling funds to rent telescope time. A retired engineer builds a homemade spectrometer out of a CD and a webcam. Another user streams a 12-hour time-lapse from Chile. You leave the feed running like a campfire. At 2 a.m, someone uploads a short clip that steals everyone's breath. The Comet, just a pixel cluster, flashes briefly, then dims. Another flare follows a minute later, then another. 3 in total. The uploader titles it Triplet Event. The comment section erupts. "Camera glitch! Cosmic ray strike! Deliberate signal!" The debate spins faster than the refresh button. You lean closer to the screen, replaying it again and again. Each flash lines up with that 4-hour rhythm, scaled down like a whisper inside a heartbeat. You know it could be coincidence, cosmic rays, satellite interference, anything, but the timing needles at you. A moderator posts a link to official data confirming nothing unusual was detected that night. The denial arrives too quickly, too perfectly worded. You remember Section 7's vanished telemetry and feel that familiar twinge of skepticism. The chat fills with theories: magnetic resonance, structural tumbling, self-shadowing. You type nothing, just watch the words scroll. It's like listening to 1,000 minds talk themselves into believing that chaos has meaning. You notice how the community has changed. A week ago they were scientists and hobbyists. Now they're something more. Pilgrims with telescopes, kneeling at the altar of uncertainty. They share sky coordinates the way others share prayers. Someone from Morocco writes, "I can't see it. Clouds tonight." Someone tell me when it breathes again. Someone from Canada replies, "It never stops." You smile, half moved, half unsettled. Humanity, united by a rock that won't explain itself. Outside your own window, the city sky's washed out, but you imagine the visitor gliding above the haze. You remember the ancient watchers who charted comets on parchment and took them as omens. In 1066, Halley's Comet appeared before the Battle of Hastings. Historians still argue whether it terrified or inspired the English troops who carved its image onto the Bayeux tapestry. Maybe the difference didn't matter. They simply needed the sky to mean something. You pour another coffee, the ritual sacrament of the modern watcher. The fan hums softly. On screen, someone overlays the comet's light fluctuations onto a spectrogram of whale songs, because of course they do, and the frequencies align disturbingly well. "The universe sings in F-sharp," the caption reads. You snort, then find yourself listening anyway. The blended audio is hypnotic, a low pulse that feels almost alive. Then a new post appears. A screenshot of a private Discord message claiming an observatory in Japan caught a faint polarized reflection. A twist in the light that implies symmetry. The sender's account vanishes minutes later. You refresh compulsively, but the message is gone. The quiet that follows is physical. You close your laptop and sit back, feeling the weight of the night pressing in through the glass. Maybe it's nothing. Maybe it's everything. You picture that crowd of invisible watchers around the planet, eyes, lenses, sensors, all locked on the same invisible traveller. The thought feels strangely intimate. Across time zones and languages, humanity has turned sleeplessness into communion. You glance at your own reflection in the darkened screen. The faint glow paints your face in blues and greens, like ghost light. "Still breathing," you whisper, unsure whether you mean yourself or the comet. From somewhere in the building below, a neighbour's television murmurs. The refrigerator clicks on. Ordinary sounds anchor you back to Earth. You realise that, for all our instruments, this is what we are, a species of listeners leaning toward the cosmic static, begging for it to notice us. And if 3I/ATLAS truly is breathing out there, be it venting gas, bending light, or performing some quiet, deliberate act, then tonight at least you're breathing with it. The forums continue to flicker, a constellation of tiny windows across the world, the digital heartbeat of a planet waiting for a rock to speak. You wake to a flood of notifications, headlines, clips, shaky translations. The world has found its next obsession. News anchors everywhere are invoking the phrase "history's forgotten alarms." It's what happens every time the cosmos gives us a riddle. People reach backward, rummaging through the archives for metaphors that make the present less terrifying. You scroll past dozens of think pieces drawing parallels between 3I/ATLAS and the celestial panics of the past. Someone posts a grainy photo of crowds in 1910 wearing gauze masks against Halley's Comet's supposedly poisonous tail. You remember reading how the French even sold Comet air pills, little vials of carbon dioxide and herbs meant to purify the lungs. Historians still argue whether anyone truly believed the Earth would pass through a cloud of deadly cyanogen gas, or whether it was all just a carnival of opportunism. Either way, the image, humans clutching bottles staring upward in dread, feels familiar. Because we haven't changed much. We still buy our fear prepackaged, just now it's in high definition. Your feed scrolls on, each century offering its own celestial cautionary tale. There's the Great Comet of 1680, bright enough to be seen in daylight, which Newton himself used to test his gravitational theories while the public prayed for forgiveness. There's the Tunguska event of 1908, when an object exploded over Siberia with the force of 1,000 Hiroshima bombs, flattening forests yet leaving no crater. People called it God's warning, though later scientists pinned it on an incoming comet fragment. Still, historians debate whether that explanation satisfies the unease it left behind. You sip coffee and watch the parallels pile up. Every epoch receives its cosmic visitor and panics appropriately. Tonight, scientists use spectroscopy and code instead of parchment and prophecy, but the impulse is the same. We mistake reflection for revelation. The morning radio hums in the background. A calm host is interviewing a historian about societal responses to astronomical anomalies. The historian laughs softly, a sound like crumpled paper. People think panic is the default, she says, but it's not. Often we respond with fascination, with ritual. During Halley's 1986 return, millions gathered just to watch. That kind of shared awe is a survival instinct too. Her words stay with you. Maybe what's happening now, the sky watchers, the endless live streams, the memes, isn't hysteria at all. It's defense through wonder. You open a new forum thread. Let's catalogue the comet scares. Within hours, it's a digital museum. Someone posts excerpts from medieval chronicles describing the hairy star that appeared before the Black Death. Another quotes a Babylonian tablet calling comets torches of the gods. The oldest entry from China dates back to 1059 BCE. Thousands of years, same streaks of light, same anxious poetry. It's comforting in a strange way. History doesn't repeat, it echoes. A user named Sky Ritual posts a long comment that goes viral. Every age gets the comet it deserves. Ours doesn't breathe fire, it just goes silent and leaves us arguing in forums. You grin. Poetic truth, accidental or not. But as the day wears on, the humour fades. News outlets start linking 3I/ATLAS to real-world oddities, subtle magnetic anomalies, satellite malfunctions, even a drop in ionospheric density. The coincidences stack like dominoes. Correlation isn't causation, officials insist, and yet the headlines sound increasingly apocalyptic. You turn off the TV, it's too easy to spiral. Instead, you dive into the actual history books stacked near your desk. You find one called Signs in the Sky, the anthropology of comet fear. You flip through, reading about how each civilization interpreted the same phenomenon differently. Romans saw swords, Chinese saw dragons, the Maya saw serpents of fire. Historians still argue whether these were metaphors or literal records of auroral displays. You realize that maybe interpretation itself is the point. The universe throws sparks, humanity tells stories to catch them. You check the observatory feeds again. Atlas continues its slow curve inward, tail flickering faintly. It's not particularly bright. but it's magnetic in a psychological sense. Everyone can feel it even when they can't see it. A commentator on a science channel says, "It's probably just nickel-rich ice sublimating irregularly." His tone suggests even he doesn't believe it. You picture those ancient nights when comets truly dominated the sky, so bright they cast shadows. The awe of it, the collective intake of breath. Tonight ours is invisible to most, and yet it commands the same reverence. The shared anxiety doesn't come from brightness, but from data. We fear the numbers more than the light now. Scrolling again, you find a small essay written by a middle school teacher. She describes showing her students a simulation of ATLAS's path and asking them to imagine what people in the future will think of us, our theories, our memes, our livestream vigils. Will they laugh at our fear, she asks, or see it as the start of humility? You close the window, unsure which answer you prefer. Later the sky darkens into its evening quiet. You walk outside, drawn by habit, by that same primitive need to look up. The air smells faintly of rain and car exhaust. Somewhere above the light pollution, that faint visitor drifts on schedule, indifferent. You think about the people who stood here before skyscrapers, farmers, monks, wanderers, staring at the same patch of sky and wondering what it meant. The continuity steadies you. You remember something a historian once said in a documentary. Comets remind us that the universe has its own calendar and we're not on the guest list. You laugh softly. True enough. Back inside, you jot a note in your digital journal. Fear and wonder are siblings. Always have been. Then, without quite knowing why, you add, maybe the alarm isn't for them, it's for us. Because beneath all the history lessons and data plots, that's the real question forming in your mind. If the universe keeps sending us these brief visitors, is it warning us? Or just reminding us we're not alone in the dark? Outside, a low rumble of thunder passes through the clouds, distant and soft. For a moment it feels like the sky itself is answering in its oldest language. Noise, light, and silence. The calm doesn't last. It never does. The first thing you notice when you open your feed the next morning isn't the comet's latest trajectory update. It's the tone. Overnight, the mood online has shifted from fascination to fatigue. The headlines all sound the same. Experts dismiss fringe claims. No cause for concern. Everything is normal. You've seen this dance before. When the noise gets too loud, the official voices lower their pitch until reassurance becomes its own form of denial. The new NASA statement lands at noon. 3I/ATLAS remains a natural interstellar object, exhibiting expected outgassing and rotational variability. You almost laugh. Expected. The word has become a prayer. Even the punctuation feels defensive. A second release from the European Space Agency mirrors it word for word as though the two are synchronized. Maybe they are. Scrolling deeper, you find tiny edits between earlier and current versions of those press releases. Whole adjectives vanish. Unusual, unexpected, anomalous. Replaced with duller cousins, variable, transient, nominal. The language itself is being sedated. A commentator on a news livestream calls it the official denial season. The phrase sticks instantly. Memes bloom overnight. Cartoon comets wearing sunglasses labelled nothing to see here. But for all the humour, the air feels different now. The scientists have gone quiet. Many of the independent researchers who posted daily updates simply stop. Their social feeds go dark, their websites redirect to generic maintenance pages. When asked, their institutions cite data review protocols. You can almost hear the bureaucratic door clicking shut. Historians still argue whether Galileo's forced recantation was censorship or strategy, whether he kept quiet to survive or to keep working. Either way, silence has always been the scholar's armour. You suspect the same armour is being reforged now. Your friend from the observatory messages again, her tone weary. They've put a publication hold on everything Atlas-related. Internal review, they say. We're not even allowed to share light curves anymore. You type back, why? After a pause, she replies, because the data lacks contextual stability. Translation, it scares them. That night, a televised panel discussion tries to smooth the rough edges. A government science advisor smiles gently at the camera and says, the internet thrives on mystery. The scientific method thrives on patience. You want to believe him? but his eyes flick sideways to someone off-screen before he finishes his sentence. Meanwhile, amateur skywatchers keep posting. They don't need authorization to look up. They share raw photos, some clearer than ever thanks to coordinated imaging. One shows a faint shimmer along the object's side, a pulse of reflected sunlight that looks almost geometric. The upload disappears minutes later. The user's account vanishes too. You open your private archive and find copies, because of course you saved them. The sequence of frames plays smoothly, the shimmer repeating 3 times. Not bright enough to be coincidence, not random either. You sit there counting intervals, 4 hours apart exactly as before. You whisper to yourself, still breathing. A sudden alert pings from your newsfeed. Unscheduled briefing announced by SpaceGuard Network. You click instantly. The live stream opens to a blank podium, flags arranged neatly behind it. A half hour later, a spokesperson steps up smiling the way people smile when they're told to. She assures the world that 3i/ATLAS poses no threat, that apparent irregularities are well within predictive tolerance. She doesn't take questions. Someone captures a freeze frame of her teleprompter. It reads, "Maintain confidence, emphasize normalcy." The image goes viral before it can be denied. You sit back, half amused, half unnerved. Humans can't even fake calm without footnotes. Later that evening, you watch a compilation of older official denial moments through history. The 1908 Tunguska event, meteorological anomaly. The 1952 Washington UFO sightings, temperature inversion. The 1996 Mars meteorite microfossil announcement, premature interpretation. Each began with excitement, then drowned in semantics. Historians still argue whether suppression preserved sanity or smothered progress. The same dynamic unfolds now. Each day brings another assurance, another carefully balanced phrase. The repetition begins to sound rehearsed. You realize this is how denial works in the age of information, not by erasing facts, but by smothering them in politeness. To distract yourself, you join a private stream run by a group of citizen scientists. They've linked telescopes across 3 continents for a synchronized watch. In whispered voices, they share real-time updates like a secret choir. Brightness stable, no tail, still silent. Their camaraderie feels more truthful than any official feed. When one telescope briefly goes offline, the chat erupts with jokes. "Government cut the cable," followed by nervous laughter. Humor again, the pressure valve. You ask quietly in the chat, "What if it's not dangerous, just different?" Someone replies, "Then that's the real danger. Different breaks control." The phrase lands heavier than it should. You imagine control rooms, rows of blinking monitors, analysts rehearsing responses to every hypothetical question. Somewhere, someone must have decided what story the world can handle. A small update slips out through an independent science journalist. Minor trajectory deviation detected, but within margin. It's the kind of line that sounds benign to most. But you know by now that within margin is code for "we're stalling." You stare at the words until they blur. Outside, the night is silent, the same hush that blankets observatories before something big happens. You think back to the first time you saw the comet's grainy image. It was just a smudge, harmless. And now it's become a mirror reflecting every institutional fear, every human instinct to tidy up the unknown. Maybe denial is the universe's favourite joke, humans covering their ears saying expected variability, while the cosmos hums a brand new song. You pour another coffee and open the window. The air smells faintly metallic, or maybe that's your imagination. Somewhere up there, 3i/ATLAS keeps spinning, the rhythm steady, the silence unwavering. You realise this moment, this global hush, this polite insistence on calm, isn't the absence of alarm. It's the inhale before one. You can feel the tension now, every headline, every whisper, every flicker of radar data vibrating with the same quiet dread. The words gravitational anomaly begin appearing in cautious bulletins, then in larger font until finally even mainstream media can't avoid them. The tone, though, stays soothing. Minor deviations observed in minor planets, likely statistical noise. You almost laugh when you read it. Statistical noise is science's equivalent of move along, but the numbers tell a different story. Somewhere between Mars and Jupiter, in the cold traffic circle of the asteroid belt, the math has started to tilt. The small bodies, Pallas, Hygeia, even a few near-Earth asteroids, are drifting off their predicted courses, Not much, a fraction of a degree. But when you model those nudges forward in time, they multiply, like a whisper that becomes an earthquake given enough distance. You open the updated orbital diagrams. Each asteroid now trails 2 lines, one dashed, one solid. The dashed shows where it should be. The solid shows where it is. The gap widens week by week, a subtle but relentless migration. The anomaly's origin? Aligned, improbably, with the path of 3I/ATLAS. A headline from the European Southern Observatory calls it a gravitational whisper. The phrase catches fire immediately, half poetic, half terrifying. People imagine invisible tides, unseen masses, or some vast interstellar hand brushing against our cosmic clockwork. Historians still argue whether similar whispers were ever recorded before. Some cite 1989, when Neptune's orbit showed tiny irregularities later attributed to measurement error. Others go back further, to 1846, when such irregularities led to the discovery of Neptune itself. Back then, the anomaly pointed to a hidden planet. What will this one reveal? You picture a crowded control room, rows of analysts leaning toward their screens trying not to blink. Someone must have noticed the pattern first, a lone intern maybe, hovering a cursor over a spreadsheet cell that refused to fit. You wonder how that felt, realizing the numbers themselves were moving, like the universe exhaling beneath your fingertips. Outside your window, the air feels heavier. Maybe it's the storm brewing beyond the horizon, or maybe you're projecting cosmic unease onto the weather again. You chuckle at yourself, but don't stop checking the sky. The community of skywatchers is restless. They've plotted the gravitational whisper's projected path across the inner solar system, a dotted ribbon weaving perilously close to Mars by late spring. A few self-styled theorists claim it's not mass at all but magnetism, or even a kind of directed pressure, like a gravity wave pretending to be a comet. You scroll through their diagrams, equal parts fascinated and exhausted. One post catches your eye, a simulation showing the asteroid belt subtly breathing, the objects oscillating together in sync. It's mesmerizing, like watching the solar system's heartbeat amplified 1,000-fold. Your observatory friend messages again. The perturbations are real. We checked 3 independent systems. Something's nudging them, and it's not random. You type back, could ATLAS itself cause that? Her reply comes after a minute. Only if it's much heavier than our models say, or if it's doing something that mimics gravity. That phrase, mimics gravity, sits in your mind like a splinter. You dig deeper into old research papers. There were once fringe theories about negative mass, hypothetical matter that would repel rather than attract. Pure speculation. Still, one scientist on a livestream jokes, maybe ATLAS isn't falling toward the sun, it's falling away from us. The audience laughs nervously. It's getting harder to tell where science ends and poetry begins. Meanwhile, observatories across the world are noticing subtle clock discrepancies, timing drifts of milliseconds. Network engineers shrug it off as sync issues, but you've seen enough movies to know that timekeeping and gravity are intimate partners. A shift in one can echo in the other. A late-night news special interviews a physicist who looks too tired to lie convincingly. We're refining our models, she says, blinking hard. Gravity is a subtle dance. Tiny deviations can cascade. Her voice catches slightly before the feed cuts to a smiling anchor promising, no cause for alarm. You scroll further down your feed and find a quote from an anonymous source, supposedly from inside the Jet Propulsion Laboratory. We've ruled out data error. Something's out there bending the math. The post is quickly deleted. Screenshots, of course, survive. It's hard not to imagine Atlas as a puppeteer tugging at the asteroid belt with invisible strings. You picture those rocky worlds trembling slightly, like marionettes unsure of their master's next move. You lean back in your chair and remember the first time you saw the comet's image. Just a soft blur, harmless. You didn't sign up for gravitational rearrangements, but here you are, watching numbers shift as though reality itself is rehearsing for a performance no one asked for. To steady yourself, you think of history again. In 1919, when Eddington observed the bending of starlight during an eclipse, he confirmed Einstein's general relativity. It was the moment gravity became elastic. Historians still argue whether that discovery was science's greatest triumph or the moment we realized the universe would never again sit still. You glance at the time, 2:47 a.m., the forums are alive again, buzzing with speculation. Some users insist this is proof of a massive core hidden inside ATLAS, dense as a neutron star. Others propose it's hollow, it's gravity simulated. One joker writes, "Maybe it's just flexing for attention." You laugh softly, even cosmic dread needs a punchline. Still, the numbers remain, the asteroids keep drifting. Before closing your laptop, you check one last update. The tracking feed overlays 3I/ATLAS's trajectory with those of the affected bodies. For a heartbeat, the lines align perfectly, a slender helix twisting through space, graceful and deliberate. Then the feed refreshes, and the pattern is gone. Maybe it was just a rendering glitch, maybe not. You sit there in the dark, the faint hum of your electronics filling the silence. The phrase gravitational whisper repeats in your mind, almost like a lullaby. If gravity can whisper, you wonder, what happens when it starts to sing? Outside, unseen above the clouds, 3I/ATLAS continues its slow drift, invisible fingers rearranging the architecture of the solar system by millimeters and moments. You imagine the whole cosmos leaning in to listen, and you, small, sleepless, and mortal, can't help but listen too. It begins with a post that shouldn't exist. No username, no timestamp, just a link dropped into one of the encrypted astronomy servers you check compulsively. The title reads, "Whistle in the Data Wind." You almost ignore it. The name sounds like late-night poetry, but curiosity wins. You click. The link opens to a compressed folder containing 4 files, each labelled with a date corresponding to the 43-minute gap that still haunts your imagination. Inside, the data looks like raw telemetry, strings of numbers punctuated by silence. You don't understand most of it, but you notice the metadata tag, Dr. Mara S. Valen, Cerro Paranal Observatory. You remember that name. She'd been one of the most outspoken astronomers studying ATLAS, the one who gave interviews comparing its trajectory to a wound clock slowly learning to tick backward. Then, a few days after the publication hold, she disappeared from every social platform. Her institution listed her as on sabbatical. You open the files one by one. The first 3 are static, typical noise. The 4th is different. There's a pattern buried in the data, an alternating sequence repeating in intervals too precise to be random. You map it into an audio spectrogram expecting chaos. Instead, you get something that looks eerily deliberate. A rising, falling whistle, soft but rhythmic, like a breeze curving through metal pipes. You play it once, twice. By the 3rd time, you swear the sound seems to breathe. Your pulse quickens. It's probably data compression artifacting, you tell yourself. Digital ghosts. But the symmetry, it's too clean. You upload the waveform into a visualization program. The peaks and troughs trace a shape like a spiral unfurling from its center. You've seen that shape before, in orbital diagrams, in the whispering drift of asteroids. You sit there half smiling, half terrified, whispering, "What are you trying to say?" A new message appears on the forum. If you're reading this, back up the files, they'll disappear soon. You glance at the username Valen Echo. For a heartbeat you think it's a joke. Then, just as predicted, the original post vanishes. 404 error. You check your download folder. The files are gone too. Deleted mid-session. Only the audio spectrogram remains on your screen, frozen mid-curve. You take a screenshot before that disappears as well. Then your phone buzzes. Unknown number, a single text. Don't share it yet. They're listening. You freeze, the words blurring for a moment. It could be a prank, sure, but it lands with a weight you can't dismiss. You step away from the desk, trying to breathe. The hum of your electronics fills the silence like 1,000 insects. You unplug your router out of pure instinct. For the first time since this began, you feel watched. Later, after your heartbeat slows, you reconnect and search for any trace of Valen. Nothing new. Her academic profile still exists, but every recent paper now lists data under review. Her colleagues give careful interviews describing her as a dedicated researcher currently pursuing independent analysis. The euphemism sounds like exile. Historians still argue whether Galileo's notes from 1610 were ever censored by his own students before reaching Rome. Some fragments suggest his most controversial ideas survived, only because copies were smuggled through back channels. You wonder if Dr. Valen's whistle is following the same path, echoing through digital corridors, carried by the curious and the sleepless. You spend the next hours dissecting what remains of the waveform. You slow it down, speed it up, invert it. Each manipulation reveals another layer of order. At one point you realize the frequency ratios match simple harmonic intervals, perfect fourths and fifths, the building blocks of music. The universe apparently has a sense of harmony. You laugh softly, rubbing your eyes. It's absurd. You're anthropomorphizing noise again. But still, what if the harmony isn't coincidence? What if the whistle is resonance? Something vibrating inside Atlas as it interacts with sunlight or magnetic fields? Some researchers theorize comets can sing when charged particles sweep across their surfaces. In 2014, ESA's Rosetta probe even recorded such vibrations from Comet 67P, tiny oscillations, inaudible but real. Historians still argue whether that discovery proved anything beyond the poetry of physics, but tonight, with your headphones on, you can't help hearing intent. You post the remaining image of the spectrogram on a private Discord server, captioned, "If anyone else heard the whistle, DM me." You expect ridicule. Instead, 3 messages appear within minutes. One from Argentina, one from Poland, one from Japan. Each claims to have captured the same pattern, different telescopes, different times, identical rhythm. One user attaches his data log. The signal strengthens slightly every 4 hours, then cut off abruptly after 43 minutes. That number again. You feel a chill creep down your arms. You ask if any of them tried converting the sequence into coordinates. A pause, then a reply. "We did." It points back to the comet itself, but offset slightly, like it's orbiting something invisible. Your brain spins, an orbit within an orbit, a satellite of silence. Another message arrives from the Polish user. Valen contacted me once, said the signal isn't sound, it's structure. She called it the framework. You blink at the words until they lose meaning. Framework. Outside, rain taps the window, soft and steady. You turn off the lights and let the room fill with shadows. In your headphones, the recorded whistle plays again, low and haunting. If you listen long enough, it almost sounds like words forming just beyond comprehension, something between language and breath. You think of Valen somewhere out there, hiding, perhaps still recording, her ears tuned to the same impossible melody. You whisper into the dark, "I hear it too." For a moment you imagine the comet listening back. The hum of your fan merges with the phantom sound until you can't tell which is which. Maybe that's how it wants it, meaning woven into noise, truth hidden inside static. You realize that you'll never again be able to hear silence without expecting it to answer. It feels like the whole planet forgets how to breathe for a day. The alerts go out quietly at first, scientific, restrained. Coordinated observation window, they call it, which sounds almost peaceful. But within hours, the phrase mutates into something more theatrical. Global night of stillness. Every major observatory from Mauna Kea to Paranal to La Palma announces participation. Satellites will pivot, arrays will synchronize, amateur astronomers are invited to join. The goal? A continuous 24-hour vigil of 3I/ATLAS as it makes its closest solar approach. You know you should sleep. You know you won't. By dusk, every channel on your feed pulses with anticipation. Live streams stack atop one another. Scientists in headsets, telescope domes opening like metallic flowers, chat windows scrolling faster than thought. The excitement feels oddly devotional. Humanity has gathered for a cosmic meditation, everyone staring at the same patch of night. You step outside to feel it. The air is crisp, thin. Even in the city, the streetlights seem dimmer, as if they too have agreed to quiet down for this vigil. Somewhere far above, a world's worth of glass and metal has turned toward a single speck. The broadcast from the European Southern Observatory begins with ceremonial calm. "We stand at a unique moment," the host intones. "For the first time in history, our species will observe an interstellar object continuously, collectively, as one." It's the kind of line you'd expect in a science fiction film. You half expect orchestral music to swell behind it. Instead, there's only wind in the microphone and the faint whir of machinery. You log into the Skywatcher forum. Thousands of users are already there, each streaming their own feed, a patchwork quilt of night skies stitched together by broadband. A user from Morocco types, "It's 2 a.m. here, my kids are asleep, I can't stop shaking." Another from Alaska replies, "Feels like the world's heartbeat slowed. The professionals keep their composure. At T-0, the synchronized observation begins. Every telescope, every satellite camera, every sensor locks on target. The planet collectively holds its breath, and then silence, not literal silence. The world still hums. But something subtle shifts. The background noise on the live streams fades into a low hiss. The digital signal meters on the screens flatten perfectly, as though reality itself has paused for calibration. You glance at the comment feed. People are noticing it too. "Audio bug," someone writes. "The static's gone." Another answers. "No, listen, it's like the air stopped." The seconds stretch. The comet's image, tiny, pixelated, remains still. Then slowly its brightness begins to pulse. Once, twice, 3 times. The same 4-hour rhythm condensed into moments. Your chest tightens. You whisper, "There it is." The main broadcast catches it too. The host's voice trembles slightly. "We're observing a brief periodic increase in luminosity." Engineers rush to adjust exposure levels. For a breathless instant, the comet flares, so bright the sensors bloom white. Then just as suddenly it dims again. Across the world, a collective exhale ripples through chat rooms and living rooms alike. Someone types, "It breathed." The phrase repeats hundreds of times until it becomes mantra. The commentators try to stay calm, talking about albedo variability and thermal stress fracturing. But their voices waver. Your phone buzzes with a message from your observatory friend. This isn't reflection, it's internal. Something's moving inside it. You stare at the text, unable to blink. Minutes pass. The comet glows faintly, steady again. Instruments record no sound, no radio emission, nothing measurable, only the light, rising and falling like a slow tide. The official broadcast resumes its polite narration, but you can hear it in their tone, or stitched with fear. Historians still argue whether the first lunar eclipse recorded by humans was met with terror or worship. Some ancient texts describe crowds banging pots to wake the moon. Others say they simply watched in silence, understanding instinctively that the cosmos doesn't need saving. Tonight feels like both at once, a planet on edge, wanting to act, choosing instead to watch. As the hours pass, the vigil takes on a strange peace. The chat feeds slow. People stop typing. The sky becomes a global meditation, millions of eyes sharing the same light curve in real time. You sit by your window, the glow of your monitor reflected faintly on the glass. Outside, a cat crosses the street, oblivious to history. Somewhere far above 3I/ATLAS drifts closer to the sun than ever before, its surface heating, cracking, singing, if the universe allows such a word. Near dawn, something subtle happens. The brightness steadies, then flickers once more, but this time, instead of fading, it fractures. The image on screen splits into 2 points of light, twin embers spinning around each other. The broadcast erupts. "Possible fragmentation event," shouts one astronomer. "We're confirming 2 bodies detected." The chat floods with disbelief. It split itself. Is this the end? Or the beginning? You lean forward, watching the 2 specks spiral closer, merge again briefly, then separate for good. The smaller fragment drifts outward, fainter but following a deliberate curve, not a random scatter. It's moving with precision. Your friend texts again. One piece just changed trajectory. It's heading toward interplanetary space, faster than before. You stare at the screen, at that smaller shard accelerating beyond predicted limits. The main body of 3I/ATLAS continues its sluggish rotation, but the fragment races ahead, like a child breaking free of orbit. The commentators scramble to make sense of it. Could be outgassing, debris ejection. Their words stumble over the data. Somewhere in the endless chat, a single comment appears and is immediately buried by thousands of others. It's sending something. You whisper it out loud, tasting the words like ash. It's sending something. The vigil ends as dawn spreads across continents. The official streams cut off one by one, replaced by static. You remain at your desk, watching the last working feed from Chile as the smaller object dwindles to a pixel, then nothing. The world will call it a successful observation, a triumph of global coordination. The press releases will celebrate the data. But you'll remember the silence, the low, synchronized hush before the light split. A global night of stillness indeed. The first night humanity truly listened together. and somewhere, beyond our reach, a fragment of the visitor is already racing into darkness, carrying the quiet with it. When the streams cut out, you think the story might finally settle, but silence doesn't stay quiet for long. Within hours of the vigil's end, the data dumps start rolling in. Terabytes of light curves, magnetometer readings, unfiltered telemetry. It's beautiful, overwhelming chaos, the digital equivalent of a global bonfire's ashes. You begin picking through them because you can't not. At first, it's all what you expect. Wavelengths, timestamps, the clean math of astronomy. Then, buried deep in a public archive from the South African Meerkat Array, you find the first mention of it. Pattern in the silence. The file is just a summary sheet, written by an engineer who clearly wasn't supposed to speculate. One line of text in all caps, intervals of missing static repeat, every 241 seconds, plus or minus 0.5 seconds, not random. You copy the phrase into a notepad and stare. Missing static. That's an elegant contradiction if you've ever heard one. You pull up the raw recording. It's the familiar broadband hiss, that endless digital sea you've listened to too many nights. Then, small voids, tiny slices of absence spaced perfectly apart. You visualize it, convert the audio to a binary waveform, and suddenly it's obvious. The gaps form pulses. The pattern isn't long, 6 groups of 3, 241-second spacing, then a long pause, almost double the interval, and it repeats. The rhythm feels intentional, like punctuation. You think of the phrase that started it all. The silence itself might be structured. At first, the idea makes you laugh. The universe writing haiku in missing data. But the laughter doesn't last, because once you start counting, the sequence won't stop repeating. The more you zoom in, the cleaner it becomes. Historians still argue whether the 1977 wow signal was human error or an invitation lost in translation. You wonder if, after all these decades, the cosmos has finally sent a sequel, but one subtle enough to slip past our disbelief. You post a screenshot of your findings on the Skywatcher's private board. Within minutes, replies flood in. Someone from Finland overlays the gaps on his own recordings and finds the same rhythm. Another user, a musician, converts the timing into notes, a slow, repeating measure in 3/4 time. He calls it the galaxy's waltz. You play the file he uploads. The missing static translates into soft tones that sound less like melody and more like breathing through glass. The room feels smaller after that. Your observatory friend texts, "We noticed it too." They're calling it the negative pulse. Officially, it's interference. Unofficially, we don't know. You ask if the signal matches the smaller fragment that broke away during the vigil. Her reply arrives after a long pause. Yes. The gaps began the moment it detached. For a few seconds, you simply stare at the message, the words haloed by your phone's backlight. The fragment left, and the silence changed shape. You turn off the lights and listen again to the recording. The gaps now sound deliberate, like coded patience. You start timing your breathing to the pattern, feeling ridiculous and reverent all at once. Somewhere online, theories multiply. Maybe the negative pulse is a natural phenomenon, a rotation period modulating radio quiet zones. Maybe it's an echo of solar interference. Maybe it's a countdown. The most popular thread proposes that absence itself is the message. A civilization that's endured long enough to cross stars wouldn't waste energy shouting, one user writes. They communicate by what they withhold. The post gets thousands of upvotes before moderators lock it. You try not to let the idea dig in, but it does. There's something unnervingly elegant about silence as a universal constant. Even humans use pauses to make meaning. Maybe the universe has simply learned to do the same. You find yourself thinking about older silent languages, semaphore pauses, Morse spaces, the rests and sheet music that give notes their power. Maybe the universe too has rests, gaps we're only now learning to hear. Outside, dawn seeps grey across the windows. The hum of your apartment, refrigerator, power lines, the distant elevator motor, suddenly feels musical, like the planet is tuning itself. You wonder if ATLAS has changed your ears permanently. You remember an anecdote from the 1800s about Friedrich Bessel, the astronomer who discovered stellar parallax. He once wrote that stars speak in numbers too vast for hearing. Historians still argue whether he meant poetry or math. Either way, you think he'd smile at tonight's discovery. By afternoon, Mainstream outlets catch on. Headlines split between fascination and ridicule. Scientists hear pattern in cosmic silence. The comet that won't shut up about nothing. A talk show host jokes, "Guess space finally found the mute button." You laugh, grateful for the levity. But the agencies aren't laughing. That evening, an updated bulletin from the Deep Space Network quietly changes protocol. All antennas now required to maintain continuous background monitoring on Atlas's coordinates for calibration. You recognize the euphemism, monitoring without admitting you're monitoring. You pull up the live spectral feed one more time. The gaps are still there, perfectly spaced, unchanged, patient. You whisper into your half-dark apartment. We hear you, or we don't, but we're listening anyway. For a moment, you imagine the fragment somewhere beyond Mars now, tumbling through sunlight, its silence punctuated by deliberate nothingness. Not a beacon, not a song, just absence arranged so precisely it feels like choice. Maybe that's all communication ever is, patterns of what we decide to leave out. The feed continues, gap after gap, a cosmic heartbeat made of pauses. You find yourself counting along, the way people count seconds before thunder, waiting for the next empty space to arrive right on time. It does, and in that tiny, perfect silence, the whole world seems to hold its breath with you. By the time a week passes, the silence has become unbearable. Not the cosmic one, the human one. The institutions, the press, even the chat rooms seem to have collectively inhaled and forgotten how to exhale. Everyone's waiting for someone else to decide what happens next. You sense it in every conversation, every headline carefully phrased to sound unruffled. Further analysis is ongoing. Preliminary findings remain inconclusive. The code of paralysis. Behind it all hums a single question, the one no one wants to voice aloud. When do we tell the world that we might be hearing something? The threshold debate, they're calling it, though never publicly. You first hear the term from your observatory friend. Her message is clipped. Cautious. Private conferences starting. They're arguing disclosure protocols, and you ask disclosure of what? She answers, they don't even agree on what it is, but they agree it's not nothing. That's how you learn about the closed-door roundtables, emergency sessions connecting observatories, space agencies, and a handful of academic representatives. No journalists, no live streams, just scientists, bureaucrats, and philosophers trying to decide when silence stops being noise and starts being message. A leaked agenda hits your feed 2 days later. The items are chilling in their simplicity. 1. Confirm persistence of structured intervals. 2. Assess probability of artificial origin. 3. Evaluate social stability risk of early disclosure. 4th draft unified public statement. You stare at that last bullet. Unified. Because nothing terrifies authorities more than disagreement. On one forum, someone posts a quote from the 1961 Brookings Report, the US government document that speculated how humanity might react to contact with extraterrestrial intelligence. The line reads, "Societies may disintegrate if confronted with beings superior to themselves." Historians still argue whether that line was caution or prophecy. Tonight, it feels like an instruction manual. You imagine the meetings, men and women in tired suits, cups of cold coffee, eyes red from too much screen glow, charts projected on walls, each one inconclusive but leaning toward impossible. Some argue for transparency. The public deserves to know. Others plead for restraint. We don't have confirmation yet. A few you suspect just want to delay until retirement. You picture your friend sitting there biting her lip, listening to people debate whether humanity is mature enough to handle curiosity. You can almost hear her sigh through the data lag. A news leak breaks the illusion of secrecy. The Guardian publishes a headline, "Inside the Cosmic Quiet, Scientists Split Over Interstellar Mystery." The article quotes an anonymous source, likely your friend or someone like her, describing an organised argument over the definition of message. It trends instantly. Within hours, every channel runs its own panel discussion. Psychologists warn of potential societal destabilization. Religious leaders issue calm statements about divine plurality. One televangelist claims the silence itself is God's voice. A meme circulates showing a cartoon Earth with a caption, "Typing, humor again, the species' favourite sedative." But underneath the jokes, genuine fear blooms. Markets fluctuate, conspiracy channels explode, and someone inevitably calls the phenomenon a hoax. It's too neat, they argue, too symmetrical to be real. We're being psyoped by the telescope industry, one pundit declares. You almost admire the creativity. Meanwhile, amateur astronomers keep their instruments pointed upward, defiant. They live-stream the gaps, the way monks might live-stream prayer. Their faith is in measurement. You tune in to one such stream late at night. The host, an older man with a calm voice, explains that the signal structure has changed slightly. The long pause that divided each sequence has shortened by exactly 1 second. Maybe it's adjusting to us, he says softly. The chat goes wild. Your observatory friend confirms the same change a few hours later. We double-checked. It's deliberate. Then another message. Some want to send a reply. Others think that's suicide. You ask, which side are you on? Her response, whichever side still believes curiosity isn't a crime. You sit with that sentence for a long time, the glow of your monitor the only light in the room. Historians will one day argue whether these days, these hushed, indecisive days, were courage or cowardice. Were we wise to pause, or did we let fear make the first decision for us? Outside, the city hums obliviously. Streetlights flicker. Somewhere, a train sighs. You think about how small we are, how fragile our collective calm really is. It wouldn't take much to fracture it. A wrong word, a misinterpreted press release, a rumour spreading faster than light. You imagine what it must feel like inside those conference rooms right now. The tension of trying to decide the emotional fate of 8 billion people with a vote. The threshold debate stretches on for days. The leaks continue. One memo, reprinted by multiple outlets, lists 3 proposed triggers for public activation. A. Repetition beyond 100 confirmed cycles. B. Detection of modulation correlated with Earth-based observation. C. Direct response to intentional human transmission. That last line makes your stomach drop, because it means some of them are already thinking about talking back. You close your laptop, step outside, and let the night swallow you. The wind smells faintly of ozone. Somewhere, someone's burning leaves. Above, the stars look the same as always. Uncaring, ancient, familiar. And yet you know one of them, invisible among millions, is no longer just reflecting sunlight. It's waiting. You think of all those silent meetings across the planet, all those cautious phrases crafted to protect a species from its own curiosity. And then you whisper, not as a scientist, not even as a watcher, but as a human being too small to make the vote matter. Tell us when you're ready. We've been ready forever. Your voice disappears into the dark, carried upward by nothing but faith and static. You don't remember falling asleep, only waking to the vibration of 100 simultaneous alerts. Every app, every feed, every message window pulses with the same headline before you can even focus your eyes, sounding the alarm. The phrase doesn't sound like journalism. It sounds like something from an emergency broadcast system. You sit up, heart hammering, scanning through notifications. Every observatory, every agency, NASA, ESA, JAXA, even the small university telescopes, has released the same short statement. Coordinated Data Review confirms persistent non-random modulation originating from the interstellar object 3I/A TLAS. Further analysis indicates synchronization with previous observation intervals. Formal announcement to follow. No denial, no hedging, just confirmation. Your first reaction is disbelief. Then, exhilaration. Then the cold, crawling awareness that the world will never again be the same kind of quiet. The broadcasts begin within the hour. A half-dozen scientists stand shoulder to shoulder in front of a blue backdrop, faces pale with exhaustion. One steps forward and reads from the teleprompter. We have verified repeating patterns in the radio silence surrounding 3I/ATLAS. These patterns meet the statistical threshold for intentional modulation. Intentional. That's the word that detonates across the planet. The feed lags as millions of viewers log on at once. You refresh, until the image stabilizes again. The scientist continues. We cannot at this time determine the source or purpose of the modulation. However, it appears to respond to specific intervals of Earth-based observation. In other words, it knows we're watching. Historians still argue whether the 1997 Phoenix event, the massive V-shaped array of lights over Arizona, was the last global moment of collective speculation before cynicism took over. But this is different. The doubt feels smaller than the awe. Your phone buzzes with a message from your observatory friend. They've decided to call it contact without saying the word. You reply, "You there for the data drop?" "Yes, it's beautiful," she writes. "Terrifying, but beautiful." Another alert. Live feed from the Deep Space Network. You open it. Rows of technicians stare at spectral graphs, all centered on one thin band of frequency. At first, it's just the usual static, grey, meaningless. Then, as the minutes tick by, the absence returns. The same pattern of missing noise you know too well, but now with subtle shifts in spacing, like syllables forming. The analyst narrates quietly, "We're observing modulation of the null intervals consistent with structured communication." His voice cracks slightly on the last word. People around the planet are hearing it too, through speakers, through live streams. The gaps play out as rhythm, and the rhythm starts to feel human. You close your eyes and listen. The pauses vary now. Long, short, long, short, long, long. It's almost Morse, but not quite. Some clever person on the forum overlays the pattern onto binary notation, transposes it to text. The result is nonsense. Another tries prime number spacing. Still nonsense. Someone jokes. Maybe it's just saying hello in a way we'll need a few centuries to decode. The comment earns 1 million likes in an hour. But a small group of linguists and mathematicians working together in a private Slack channel publish something extraordinary. They've noticed that the newest gaps correspond precisely to the times of our telescope transmissions, delayed by the travel time between Earth and the object. Each time we ping it with radar, the silence shifts in response, like call and answer. That's not coincidence, that's conversation. Your observatory friend sends another text. "We've confirmed reciprocity." It's answering. You stare at the words until your vision blurs. Outside, the city sounds different. The usual noise, sirens, cars, voices seem subdued, cautious. People are watching screens in windows, on sidewalks, in cafes. The world has synchronized in wonder. Another alert flashes, global message draft in progress. You flip to a newsfeed. The United Nations, the SETI Institute, and every major communication agency are coordinating a single transmission, a unified human response. For once, no one wants to act alone. They're calling it the longest transmission. A leaked draft circulates within hours. A simple signal, binary pulses spelling out the numbers 1 through 10, followed by the chemical signatures of life: hydrogen, carbon, nitrogen, oxygen, and a sequence encoding the position of Earth relative to pulsars. It's clean, humble, almost shy. A cosmic handshake offered without pretense. But not everyone agrees. Debate explodes online. Should we answer at all? Some warn of risk, of revealing our location to forces we don't understand. Others argue it's already too late. The universe knows we exist now. You watch the chaos unfold in real time. Humans arguing, pleading, hoping, fearing. And then, amid the noise, one comment catches your eye. "We've been shouting into the void for a century," it finally whispered back. "Don't leave it hanging. That settles it for you." As night falls, the global broadcast begins. In a control room somewhere, a technician counts down. Transmission commencing in 5, 4, 3. The signal is simple. 10 pulses, a pause, 10 more, another pause. The room goes silent. The world goes silent. The transmission ends after precisely 1 minute. It will take 23 minutes to reach 3I/ATLAS. Then another 23 for any reply to return. 46 minutes of global stillness. You open your window, letting the night air in. Streetlights glow like patient stars. The seconds tick away. You imagine the signal racing through space, a line of digital light threading toward that strange blue-green object. Half an hour passes, then 40. Then right on cue, telescopes everywhere register a shift. The silence modulates again, but this time the pattern is unmistakably different. Structured, balanced, deliberate. The data renders into a spectrogram shaped like symmetry itself, 2 arcs converging, then parting again. A waveform that looks, impossibly, like a mirror. The translation teams don't even try to assign language. The image speaks plainly. It's acknowledgement, not greeting, not warning, just recognition. And just like that, the debate ends. The alarm isn't a scream, it's a chord, the sound of the cosmos noticing us noticing it. You sit there until dawn, watching the graphs fade, your hands trembling not from fear but from awe. Somewhere far beyond the sun, a fragment of 3I/ATLAS glows faintly. whispering its deliberate silence back at us. We have sounded the alarm, and something answered. It happens quietly, almost too quietly for what it means. The confirmation ripples across the network. The signal wasn't a glitch. It repeated, perfectly, after the expected 46-minute delay. Not just once, 3 times, identical each time down to the millisecond. It's no longer a question of if, it's a question of what next. The phrase "the longest transmission" takes on a new gravity overnight. Governments coordinate, committees expand, and every language on Earth seems to lean toward the same vocabulary: message, answer, echo, mirror. The media calls it the moment. You can feel the capital letters in every headline. The global mood is strange, half sacred, half practical. Some people light candles on balconies, others argue over what the next signal should contain. The rest simply stare at the sky, eyes glazed with something between hope and terror. You can't sleep. No one can. The world's circadian rhythm is out of sync. Your observatory friend sends an encrypted message. It's official. We're drafting a reply. They're calling it Echo 1. You type back, "What are we saying?" Her answer comes minutes later. Math first, then music. Music. You reread the word 3 times. Apparently, the International Task Group decided that the most universal language isn't language at all. It's ratio, rhythm, resonance. If the signal we received was symmetry, then maybe harmony will bridge the gap. The first half of Echo 1 will transmit prime numbers again, just to confirm mutual awareness. The second half will be a simple waveform translation of the well-tempered clavier, Book 1, Prelude number. 1. Bach, our species' proof that order and emotion can coexist. The irony isn't lost on anyone. The last time humanity played back into the void was with the Voyager Golden Record, launched in 1977. Historians still argue whether that was bravery or vanity. Tonight it feels like a continuation. The official countdown begins 12 hours before transmission. The world holds its breath again, but this time there's music involved. Cities broadcast the prelude in public squares. Choirs hum it softly in subway stations. Somewhere, a little girl plays it on an out-of-tune piano and doesn't even realise she's joining a global chorus. You open every live stream at once. Control rooms glow in synchronised blue light, technicians calm but trembling. At 0000 UTC, the transmission begins. A single, sustained tone, a digital C major, flares from every antenna across the planet. It's the purest note you've ever heard. The prelude follows, simple, cascading progressions of sound converted into pulsed light, sweeping across space toward that faint interstellar traveller. For the next 4 minutes and 40 seconds, Earth sings. You imagine it leaving our atmosphere, that radiant braid of radio and laser, threading through planetary orbits, brushing the edge of the asteroid belt, racing toward ATLAS's quiet twin. Then silence again. 46 minutes of waiting. You step onto your balcony. The night air feels electric, alive with invisible frequency. Below, the city is still. No sirens, no chatter, no traffic. Just the hum of anticipation. 40 minutes pass, then 41, 42. The live streams stutter from server overload. 44, 45. Then, right on cue, every receiver on Earth lights up. The returning signal begins faint, then swells. The pattern matches ours perfectly until the final measure, where it changes. The last few pulses bend upward, stretching into a new chord, minor to major, dissonance to resolve. It's unmistakably a response. Analysts scramble. The tone isn't random, it's relational. The pattern mirrors our Bach prelude but resolves it differently, as if the cosmos has improvised a harmony. The feed explodes with awe. Scientists cry openly on camera. You find yourself laughing, then shaking, then both at once. Someone in the chat types, "They understood." The phrase repeats endlessly. They understood. They understood. It's easy to forget how long we've been waiting for an answer. Not decades, but centuries. Every fire lit on a hilltop, every radio pulse, every telescope pointed outward has been a rehearsal for this moment. And now it's here. Not as a roar or a revelation, but as a quiet duet. Your observatory friend sends a single text. "We did it. We're not alone." You type back, but your fingers hover. Useless. What is there left to say? Historians will one day debate who authored the response. if there was ever an author at all. Some will claim it was automated feedback, a natural resonance triggered by our signal. Others will insist that the universe itself became a participant, echoing us like a hall built for sound. But for now, none of that matters, because somewhere beyond Mars that fragment of 3I/ATLAS still tumbles, silent to the eye but alive in radio spectrum, humming back our melody in its own voice. And for the first time in human history, the void has rhythm. You remember reading once that in ancient Greece, astronomers believed the planets produced music as they moved, the harmony of the spheres. They thought if you listened hard enough, you could hear creation itself humming. Historians still argue whether that was superstition or genius. Tonight it feels like prophecy. The official channels call for calm, but calm is impossible. Around the world, church bells ring without permission. Crowds gather in streets, not to protest or panic, but simply to listen. Radios, phones, televisions, every speaker alive with that single looping chord. For one long night, humanity forgets how to argue. At 300 hours UTC, the global feed releases the final processed spectrogram. The pattern resembles two mirrored spirals converging at the center, like galaxies reaching for each other. Beneath it, a caption. Echo 1 received. Harmonic correspondence confirmed. You whisper the words under your breath like a prayer, and as the night deepens, the harmony lingers. The silence between stars doesn't feel empty anymore. It feels inhabited, resonant, aware. You sit by the window until dawn, the faint hum of the universe in your ears, realizing that the alarm we sounded wasn't a warning at all. It was a chord waiting for an answer, and the answer came. By dawn, the world feels different. Not louder, not brighter, but tuned. Even before the headlines start their chorus of words, contact, echo, correspondence, event horizon of meaning, you can feel it under your skin, a vibration, subtle as breath, humming through everything that holds a charge. The city hums in key. The scientists call it after resonance. Technically, it's nothing more than a faint bleed in the electromagnetic spectrum, a ghost of the transmission still bouncing inside Earth's ionosphere. But poets, priests, and anyone else who trades in metaphors are already calling it something else. The reply's shadow. You sip coffee that's gone cold and scroll through feeds that refuse to stop updating. There are pictures everywhere, screenshots of the returned spectrogram, cropped, framed, painted, tattooed, turned into memes. Someone sells t-shirts printed with the waveform and the caption, "We're in the band." Someone else builds a ringtone. Humanity, always quick to merchandise awe. Your observatory friend texts, they're naming the smaller fragment ATLAS2 now, the one that answered. You type back, "So, what happens next?" Her reply comes seconds later. Nothing, probably. It's leaving. You blink. Leaving? Accelerating beyond solar escape velocity, she writes. We're losing the signal. It's heading out of the plane toward the Perseus arm. You stare at the words until they start to drift. It makes sense, of course. Whatever it was, whatever it did, its visit was always temporary. But the thought hits harder than you expect. The idea that the first voice to answer us is already fading into silence again. Outside, the morning light feels too gentle for history. A group of neighbours huddle on the sidewalk, sharing a portable speaker that plays the received harmonic loop on repeat. None of them speak. They just listen. The sound is soft, round, almost like wind through organ pipes. You remember the earliest recordings of the Voyager Golden Record? Those songs, those greetings, the heartbeat of a woman encoded into copper. The spacecraft have been travelling for nearly half a century now, still whispering our hellos into the dark. And now, finally, something has answered, even if only to wave as it passed. Historians will argue endlessly about what it meant. Some will say we proved we're not alone. Others will insist we simply heard ourselves reflected in cosmic coincidence. Both might be true. For the scientists, the work doesn't stop. Papers sprout like mushrooms after rain on the harmonic correlation of ATLAS2, temporal modulation, and possible information density, semiotic frameworks for interstellar music. Conferences are announced before they even have speakers. But beneath the academic noise, the world itself is strangely peaceful. No panic, no apocalypse, just a collective awe that refuses to fade. For one impossible night, 8 billion minds synchronized, and the echo hasn't died out yet. You wander through online forums reading people's confessions like prayers. One writes, "For the first time in my life, I feel small and okay with it." Another says, "Maybe that's all heaven ever was, a successful call." A few cynics grumble about funding, about distractions, about attention spans, but even they sound softer, as if arguing inside a cathedral. That night, the UN holds a symbolic ceremony, a closing of the transmission window. No speeches, no flags, just silence broadcast across every available channel. Every TV, radio and phone goes quiet for 60 seconds, the longest collective hush in human history. It's supposed to mark the end of the experiment, but instead, it feels like punctuation. A long, soft exhale after centuries of talking to ourselves. You stand by your window again, watching the city lights blur in the glass. Somewhere far beyond them, ATLAS-2 slips into darkness, its faint hum fading beneath cosmic background noise. You imagine it still turning slowly, whispering its final pulses into the void. Maybe other civilizations will hear it next, another echo in an endless chain of replies. The hum in your ears doesn't stop, maybe it never will. Historians will keep debating, because that's what we do. Whether 3I/ATLAEs was probe or accident, consciousness or coincidence, miracle or mirror. Some will even claim the whole thing was a shared illusion, a collective wish strong enough to bend probability. And maybe that's fine too. The truth doesn't need to agree with us. You sit back down, close the blinds and let the room darken. The fan hums its usual steady note. The refrigerator clicks. The city outside breathes. For the first time, every sound feels connected. One long continuum from the smallest human noise to the faintest cosmic chord. You whisper, "Safe travels, Atlas," and smile at the absurdity of saying goodbye to an object that will never hear you. But the words feel right anyway. Maybe that's the real gift it left us. Not proof of company, but a reminder that the act of listening is its own form of faith. As you drift towards sleep, the silence outside grows deep enough to feel tangible. It isn't empty anymore. It's full of possibility, like the pause between two notes that might, any second now, resolve into a new harmony. You think of the message humanity sent, numbers, music, coordinates, and how, when the reply came, it didn't offer answers or threats, just reflection. A reminder that in the grand equation of existence, meaning is symmetrical. Somewhere beyond the reach of our telescopes, the echo fades, but the resonance remains, woven into airwaves, architecture, heartbeats. The universe has sung back, and for once, we kept time. You exhale, eyes half closed, the hum of the planet and the faint pulse of the cosmos folding into one continuous sound. The alarm has been sounded, but no one runs. Instead, we listen. And in that shared infinite pause, the silence becomes something beautiful. Proof not of danger, but of connection. Proof that the space between us was always meant to ring.